I'm going to
You're already on.
Yeah, testing. Does this? Cool. Oh, am I on? That's better.
Seems to be fine.
Cool.
He'll give you the signal when you back up. But I could use your training, you know. So Dennis in the red shirt. So you can show him what to do, maybe sit with him for the first session.
He doesn't know what.
Good, thank you. I'll see you again, man.
We're good. Stage is here. We're unmuted. It's on there. I don't mind that. Or I could just build it here. I think that's what you. Oh, it's on YouTube. How do I get it? Let's go to YouTube. Search for how what's the. Oh, Dallas. Dallas. Do over. It was the yeah, this is breakthrough. I'm sorry, Goldberg's recipe. Hello, this is Dennis. This is doing
Yeah.
something over there?
What? No, just good to go.
Yep.
All right. Let me see. All right. Good morning, Gumshoes. Today I'm here to share a case that landed on my desk not too long ago. You might say this is all the makings of a classic cloud mystery. It started like they always do, with a phone call. Major customer, real big account, reporting errors. Support tickets were piling up faster than coffee cups on an all-night stakeout. And then came the words that make every cloud detective's stomach drop. If this doesn't get canceled by the end of the quarter, we're canceling our contract. The customer's reports were vague. They kept saying, sometimes things spin for a few seconds, and then an error page pops up. But the issues were intermittent, with no clear pattern, and different users were all affected. On our end, everything looked fine. Health checks were green, traffic patterns were normal, and our application log showed no signs of trouble. In fact, every request was completed successfully. It was a classic mystery, a ghost in the network. Louder? Okay, yep. If everything seemed to be working, where were these requests going? Why couldn't we see what the customer was seeing? It was as if the requests were disappearing into a black hole. Today, we're going to solve the mystery. We'll meet the suspects, examine the evidence, and master the tools you'll need for a case like this. And I promise that by the end, you'll know how to map the territory, track down elusive bugs, and most importantly, prevent future cases from haunting you. Because if there's one thing I've learned in all my years of debugging, it's that the cloud may be someone else's network, but the detective work, that's all ours. First, let's talk about some of the greats. Sherlock Holmes famously said, as you eliminate the impossible, whatever remains, however improbable, must be the truth. In our cloud detective work, this translates to systematically eliminating components until we find the culprit. For example, if we see the same behavior, whether we go through the CDN or around it, we can remove the CDN from our suspects list. But like Holmes, we need to be methodical. No jumping to conclusions without evidence. Benoit Blanc tackles cases by breaking them down into fundamentals, means, motive, and opportunity. Let's map these to our cloud problems. Means, which component could technically cause the failure? Motive, which behaviors or situations would trigger the issue? And opportunity, which components live across the request path where the error happened? Finally, we have Columbo. His persistent questioning and just one more thing approach can be incredibly effective. In our world, this means diving deeper into assumptions and asking just one more time, are we sure there hasn't been a firewall change? All right, Gumshoes, every good detective knows you don't start an investigation without the right tools. Documentation, request flow diagrams, and runbooks are essential ingredients to solving a case. Every cloud detective needs solid documentation, because trust me, in cases like these, the devil is always in the details. First things first, we need to know what we're dealing with. And your architecture docs should help you understand service boundaries, where one team scope ends and another begins, network paths, where the route your requests should take, and integration points, where services meet and mistakes happen. Next, your request flow diagram. Think of this as your victim's timeline. Where do they go? Who do they talk to? And what should have happened at each step? Ideally, the request flow diagram shows the complete journey of a request, both upstream and downstream. Many teams meticulously document their downstream dependencies, databases, caches, backend services, but treat upstream components like a black box. This is a classic cloud mistake. A bug in your API gateway will break your user's experience just as thoroughly as a database failure. So document everything with equal care and precision. We need to know the latency expectations, timeout policies, and retry logic across your entire request path. Finally, the runbook. This is our go-to guide when things start getting messy. It should cover common problems, known resolution steps, and context for each system. A good runbook is like a case file. At the top, you've got your most wanted list, the common suspects that cause the most trouble. And for each one, you document the victim statements, say user reports timeout errors when uploading files, the evidence, load balancer logs show 504 errors, known associates, which systems are typically affected, and the usual solution, check CDN upload size limits. But here's the real trick. You want to organize it by what your victim reports and symptoms, not the root cause. Your 3 a.m. brain will thank you later. A bad example might be memory leak detection and resolution, while a better example would be 502 gateway errors. What you'll see, users reporting errors after midnight. Common causes, memory leaks in the processing service. Quick fix, restart processing nodes. Long-term fix, memory leaks tracked in Jira 133K. And always include team contacts, who to wake up at 3 a.m. Required permissions, because there's nothing worse than lacking access in a crisis. links to dashboards, aka your surveillance cameras, and links to past incidents, because criminals often return to the scene of the crime. Now, no detective goes to a crime scene without their forensic tools. And when it comes to the cloud, we've got some powerful options. First up, observability tools. Think of these like your magnifying glass, zooming in on the details to reveal what's slowing down or breaking requests as they travel through your system. These are best for understanding the full request flow and identifying bottlenecks. In a case like ours, these tools could reveal if a request is getting delayed or stuck at a specific component. Unfortunately, these are usually integrated at the application level, and sometimes trace information is missing at higher levels of the cloud network stack. Logs are like witness statements. They give us timestamps, error codes, request IDs, and client information. But just like in detective work, you need to know which logs to look at. System logs, network logs, load balancer logs, they all tell a different piece of the story. When combing through the logs, pay attention to patterns, reoccurring errors, suspicious gaps in activity, or specific times when issues spike. These can help pinpoint a problematic service or an unusual time of day. But remember, gumshoes, logs can lie by omission. Sometimes the most important clue is what's missing. Finally, there's nothing like seeing a user's perspective to bring clarity to a case. User journey recorders let us watch the crime from a user's point of view. Tools like Sentry, LogRocket, or FullStory record and replay user interactions on a website. They can be an invaluable source for clues because they often contain full network logs from the user's browser. When a request disappears or errors don't show up in our own logs, these tools can give us that missing perspective. What we see what the story as the user sees it, and that can be crucial to solving the case. Any good detective knows that a crime doesn't happen in a vacuum. There's a whole scene to examine, and in the cloud, our crime scene is vast, layered, and often underdocumented. Most people picture the path as simple, from user to cloud to app. But in reality, it's a complex web, a whole network of services with checkpoints, and each with its own quirks, configurations, and points of failure. So let's break down this crime scene, one step at a time. Because to solve this case, we need to understand the exact path each request could take. Let's meet our cast of characters, the usual suspects in any cloud caper. The DNS has a notorious reputation. Its job is to translate names to addresses, routing requests to the right place. But if the DNS isn't working correctly, your users will never find your application. Issues here can include propagation delays, misconfigurations, and cache problems. The old pro tip when dealing with any sort of DNS change is to drop your TTL settings down to about 5 minutes, 48 hours before a major DNS change, so you can quickly recover from any mistakes, and only bump it back up to 24 hours once you're confident the entire system is working, not just the DNS. Next, we have the CDN. These were originally built as large caching systems, storing content close to users by placing copies in key locations worldwide. In recent years, their role has grown. Now they run code directly at the edge, using services like Cloudflare Workers or Lambda. Common cases involving the CDN include cache poisoning, when stale or incorrect content gets stored and served, regional routing mishaps, when traffic gets sent to a distant edge node instead of a nearby one, configuration drift between edge nodes, what works in one region fails in another, and edge function timeouts, because code running at the edge typically has stricter limits than your application. A pro tip for CDN investigators, always check the cache control headers. I've seen many a case where a misconfigured cache header led to content being cached when it shouldn't be, or worse, not cached when it should be. Once any company reaches a certain size, incentives push them to install a WAF, or web application firewall, in front of all web traffic. WAFs are good at filtering requests, enforcing rules, detecting bots, and limiting rates. But sometimes, legitimate requests get caught in its net. Rate limits and low-quality IP filters are common sources of problems that might originate in the WAF. So keep an eye out if you have a particular feature that triggers a flurry of web requests, or if your customers like to use a VPN to access your website. Our load balancers are responsible for distributing requests across multiple services to keep things running smoothly. But when misconfigured, they can cause an uneven distribution, overloading some services while others are happy. Misconfigured timeouts or sticky sessions are other common problems. Your application server might be completing a request, but the user still gets an error if the load balancer gets sick of waiting and closes the connection before the app was done. Next, we have API gateways, including request routing, rate limiting, and sometimes authentication. Common issues that crop up here are routing mismatches or configuration drift, sending traffic to the wrong service. Authentication issues are also common at this layer if the API gateway and client aren't configured correctly. Kubernetes ingress is another tool for routing external traffic to services running inside your Kubernetes cluster. It acts as a gatekeeper, managing how traffic flows to your cluster and directing it to the appropriate pod based on routing rules. A common issue with ingress is misconfigured routing rules. If these rules don't align perfectly with your app's expectations, requests can get lost, redirected, or blocked entirely. For example, a typo in a host rule might send traffic intended for your service to a dead endpoint, leading to 404 errors. Another frequent challenge is dealing with the behaviors of different flavors of ingress controller. Each one has its quirks, so find out which one your company uses because you can't always trust the default documentation. Firewalls block or allow traffic based on rules, port filtering, and network segmentation. If no requests are making it to your application server, it's possible your firewall isn't allowing any traffic from outside the network. Unfortunately, I found they don't log much. They don't explain much, they just block. Blocked ports or rule conflicts are common reasons that traffic might be getting dropped before it can access your internal network. Finally, we have the application servers. I'm sure you're already imagining why this is on the suspects list, so I won't bore you with its full rap sheet. Every one of these components was built by engineers like us. Each service, whether it's a load balancer, an API gateway, or a CDN, is just another software solution. And each one has logs, metrics, and configurations. We can debug these just like any other service. It's easy to get intimidated by cloud infrastructure, to think of it as some mystical black box. But at the end of the day, we're dealing with code written by developers like us. Understanding ownership is crucial too. If we identify an issue and say, the load balancer, we need to know which team manages it. At some point, we need to know who to call when we need backup. And just like in old-fashioned detective work, building relationships is crucial. While detectives read fingerprints and tire tracks for clues, cloud detectives need to master their own form of evidence analysis. Fortunately, most cloud services speak a common language, HTTP. Status codes, response headers, and response bodies are fingerprints. They tell us who last touched a request and what happened along the way. But there's a catch. Just like with forensic evidence, we need to know how to read these clues correctly. Let's start with our 400-level status codes. These are your client-side errors, but don't let that fool you. The client isn't always to blame. 400, bad request. Some common causes include request headers being too large, so check your cookies, or malformed request values. When you find evidence of a 400, some common suspects include firewall rules, load balancer limits, or proxies. 401, unauthorized. A 401 usually means that authentication details are missing or incorrect. A common suspect here is the API gateway, because these are often coupled to authentication logic. But also make sure to check if headers are being preserved across your proxy chain. If something upstream isn't forwarding your authorization or cookie headers, then downstream services won't be able to authenticate the request. 418, I'm a teapot. Yes, this is real, and no, you're probably not trying to brew coffee in a teapot. In modern systems, web application firewalls have adopted this classic April Fool's Day joke to use as a unique signal to help cloud detectives like us know we should be taking a closer look at the WAF configurations. 429, too many requests. Our rate limiting friend. If you see a 429, it means some component, usually an API gateway or a WAF, is putting the brakes on your traffic. Double check rate limit configurations and traffic patterns. If you've got a bursty feature, that could be the cause. 500, internal service error. This is the all-purpose something went wrong code. 9 times out of 10, when you see a 500, check your own application first. Most of the usual cloud suspects are well-behaved and robust, so they typically don't break in unexpected ways. But you can never say never. 502, bad gateway. This usually means something is misconfigured in your request chain. The most common issue I've seen is around HTTPS certs preventing upstream services from forwarding requests to a downstream service. CDNs, API gateways, and even your application could all be to blame here because the issue usually involves some missing assumptions on both sides of the request. 503, service unavailable. This code usually means that a service is overloaded or temporarily unavailable. Health checks and resource utilization are the best places to start here. If you see this regularly, it could be a capacity issue. Deployments and maintenance modes are other common causes for this issue. 504, gateway timeout. This usually means that the request started timing out somewhere along the way. When you see a 504, start checking timeouts on load balancers, API gateways, and firewalls. Often it's a case of one component's timeout expiring before another component has finished processing the request. And besides these common status codes, make sure to check the docs for your CDN or cloud vendor. AWS, Cloudflare, Nginx, and others all document a list of non-standard HTTP status codes they use to provide additional context and nuance for cloud detectives. Response headers are like breadcrumbs left along the request path. They can tell us where a request has been and give us clues about any changes made along the way. CDN headers reveal where a request has been cached, how it's traveled, and whether it was served from cache or origin. If requests are misbehaving, check if they're being routed to unexpected regions, or if stale cache entries are causing issues. Application headers, like X powered by, can often be useful for pinpointing an error. Pro tip, when investigating headers, don't just look at what's there. Look for what's missing. If your application always returns X powered by Spring, but it's missing from a request that has an error, it might be the clue you need to rule out your application as a suspect. The response by itself can reveal the origin of error. Standard error pages often give away the culprit. Nginx and Apache include unique signatures in their HTML error documents, while API gateways often default to JSON responses instead. Load balancers like to take a Spartan approach to reporting errors and typically only return the status code and header. They prefer an empty body so they can spend more time serving other requests. The layout and content of an error page can be the clue that confirms the involvement of a particular error component. Building an evidence file means keeping a record of every status code, header, and response time for each problematic request. Make sure to note things that seem out of place or don't align with your mental model of how the system works. Not only does writing this down help with the current case, but over time, it builds a pattern library we can use in future investigations. Each clue adds to our case profile, helping us detect anomalies faster next time. And as you collect evidence, refer back to your architecture diagrams. See where requests might break down and try to figure out if that aligns with the evidence. Gumshoes, we've been through our toolkit. We've met the suspects and learned how to collect evidence. Now it's time to revisit our opening case. Let's dive back into the story of the phantom request, the one that would intermittently vanish, leaving a major customer frustrated and our team stumped. First step in any investigation, map the crime scene. So we trace the request journey from user to CDN to WAF to load balancer to API gateway to Kubernetes ingress and finally to our application. 6 different places where the request could vanish, 6 suspects in our lineup. Let's review what we knew. The customer was reporting timeout errors, different users were all affected with no clear pattern, and our application logs all showed success. I think we have enough info to start forming hypotheses. So let's start with some of our usual troublemakers. First, we asked, could the requests be getting lost before they even hit our servers? DNS caching, regional routing at the CDN, or SSL misconfiguration had all led to partial site outages in the past, but the evidence didn't line up. Usually a DNS or CDN error have more of a consistent pattern and don't strike intermittently. The customer should have noticed the entire site being down, not just issues with a handful of requests. Our WAF is our next suspect because it has a reputation for unpredictability. Its rules, a mix of rate limits, black boxes, and IP block lists, make it hard to tell why it stops some requests while waving others through. However, the evidence didn't match our WAF. It usually returns a 418 status code for blocked requests. At this point, we also discovered a critical clue. Customer requests were in our application logs. Timing and user IDs lined up perfectly. The only wrinkle was that the application was reporting a 200 status code, which didn't match a 504 timeout the customer saw. But this discrepancy pointed to a breakdown in the response journey. So looking at our evidence, a 200 in our logs, but 504 on the client, means something's giving up along the way. Since the load balancer is directly in the middle of our network stack, it's a good place to start, because if it isn't the culprit, it should help us narrow down the suspects to one of the services that comes higher or lower in the network stack. So we pulled the logs from the load balancer, and that's where we found something interesting. A handful of requests were taking just over 30 seconds to complete, around 31 or 32. But our load balancer had gotten impatient. It had a timeout set to 30 seconds. We'd found our guilty party. So now that we knew the problem, we were ready to fix it. So we increased the load balancer to timeout to 45 seconds. This gave us the application enough time to complete the longer running requests. We also had to verify that the timeout rules on the API gateway, Kubernetes ingress, and application to ensure that they matched up. It wouldn't do much for the customer if we bumped the timeout at one layer, only for the same issue to catch them and another hop along the journey. So some lessons learned. 1, documentation is critical. It would have taken us forever to discover this issue if we didn't have a request diagram to help us understand where to look. Not only that, now that we know timeouts can be an issue, updating the runbooks with the timeout settings will save us and our colleagues future headaches. A well-documented system makes these cases easier to solve and prevents similar issues from cropping up again. End-to-end visibility is key. We couldn't accuse any suspect until we had some evidence to help us understand what was going wrong. Distributed tracing, consistent logging at each layer can go a long way to helping you discover the root cause. And misconfigurations are a frequent culprit. In fact, most cloud networking bugs happen in the gaps between services. Each component was working correctly, but they weren't in sync with one another. So Gumshoes, we've come a long way. We've unpacked the tools, met the suspects, and walked step by step through a real-life case. If you remember anything from this talk, I hope you take away the following tools for your future cloud mysteries. Start with evidence, not assumptions. Gather facts first, document the observations, and let the evidence guide your investigation. Document everything. Keep your architecture diagrams current and update those runbooks after every incident. Build relationships with system owners. The cloud is too big for any one person, so get to know your infrastructure teams. Share your findings with them and learn from their expertise. And remember, every system was built by engineers. All systems are code, all code is bugs, all services have owners, and all problems are solvable. Thank you all. My name is Brendan McLaughlin, and I'm a cloud detective at CarGurus. If you're curious about what's complex or crunchy, about interfacing with the auto industry, or you just want to trade stories about solving tough technical problems, I'd love to chat with you. If you're local, I also want to give a shout out to our sister company, CarOffer. It's a fantastic place to work, and they're doing some really exciting things in the automotive space. I'm active on several social networks, which I've listed on the slides. If you like this talk, or if you have feedback, I'd love to hear from you. Post about this on your social network of choice, and please tag me. Not only do I love connecting with other engineers, but I also like to collect a little social proof for my boss. Thank you.
It seems like if I'm trying to get into this, are there any platforms or resources to do an emulation of these scenarios or?
Yeah, let's talk after because we're actually running short on time, but we can sync up. Yeah, sorry.
Good. So this one. Okay. Just make sure. Yep. It's good working? We're live? Okay. Hi, everyone. My name is Ali Ibrahim. I'm a solutions architect at Microsoft. I know in the agenda it's showing Amazon, but I left Amazon. So currently, I'm with Microsoft. So today we're speaking about API management, and it's a topic that you may not think it's fit for the cloud. You may not think it's fit for the developers, but it fits for both. So quick intro. As I mentioned, I'm Ali Ibrahim. I'm currently working as a technology specialist, a fancy name for a solutions architect. So my background is in development. I moved into DevOps, system admin, and I worked in cloud since 2016, 2015, something like that. My most domains, as I mentioned, I work also in Kubernetes, serverless architectures, and GitOps. I like to simplify things for developers because I'm originally a developer. So that's why I picked that topic and want to speak about. So before we start and to level set, let's speak what is an API first. So APIs, as per definition from IBM and maybe from Postman, it's a set of protocols that enable different software components to communicate and transfer data. So very fancy description that probably didn't understand anything of. So the acronym API is shorthand for Application Programming Interface. In a shorthand, it's kind of a contract. It's a contract between the developers and the developers, but both on the different side of the spectrum. So we have a developer who is providing services and a developer who's consuming that service. And the contract is made to transfer data. So how the consumer developer can expect the data to come and how to ask for it, how to request the data, and how to expect the data to be presented to them. So some of the examples, you can think of commercial APIs, like if you go to Best Buy, for example, or like you were just finished the Black Friday sales. So if you want to buy anything, those are sent as APIs to the service providers from the back end. Of course, you're interacting with the front end, but on the back end, the front end is sending the API, a request to the service provider to request whatever, like listing, show me all the laptops that you have on Amazon, maybe show me, give me the best deals you have, something like that. So those are all APIs. You can think also of social media as some kind of APIs. And this is like that evolved from the early 2000s when Facebook started to come and Twitter and all these things. If you're watching a post, if you're scrolling your news feed, or if you're posting or commenting, all these are APIs sent to the back end of Facebook or of Twitter or of anything like that. We have also other APIs that deals with data, especially if you're having now like Ring and all the IoT devices and metering devices and all these things. They are all sending data every time. And to consume these data also on your when you're paying your bills or something like that, you can see the chart of your data. This is also going as an API to the back end and receiving that. And one of the very famous APIs are the cloud APIs. So if you're dealing with AWS or Azure or anything like that, when you request an S3, for example, when you go and create a Lambda, or when you create a virtual machine, this is an API that goes to the provider, or like Amazon or Azure or anything like that, and they get the data out of this API call, the request, understand what you want. Maybe you want a virtual machine with 16 gigs of RAM and 4 cores, and try to provision that on the back end. But with those APIs, you can face some challenges. If you're the one who's providing the APIs, if you're the API provider, you can face challenges creating your APIs. So one of these challenges are authentication and authorization, and combine both together. So you don't want to provide your APIs to everyone, and anyone can access it. Like, for example, let's take again the cloud example that we mentioned. If you're working on Azure, you need to subscribe first to Azure, and you get an ID, a user ID, and this is where you can speak to Azure and request, because you cannot request a very big resources. Otherwise, Azure will block you because you don't have access. So, okay, they know that you are the user, and this is the authentication part. But they know also, because this user is on the free tier, he doesn't have access to maybe 500 GB machines. Or on AWS, for example, you have access to the resources, but you cannot expand it beyond this limit. So that's authorization. So first, we need to know who you are when you log in. Second thing, we need to know what you're able to do, and that's with authorization. And those things, the API itself should take care of, like the back end of the API. Another challenge is caching. How many of you are front developers here? Front-end developers? Okay, so probably we're dealing with Redux and some caching. You don't want every request to go to the back end and fetch the data from the database, because there are latencies. So to go and get the data, there are some latencies. And sometimes for the user experience, it's better to be fast. And instead of going back, you just cache the data if it's something that doesn't change frequently. And you can respond back from that cache. So that caching you need to manage, whether with Redux, if you're putting that into an application on the cloud, or even on-prem, you need to set up your maybe Redux cache or Elasticache or something like that to handle this caching. One of the other challenges is security. So now you have your API. Your APIs, once it's public, you can face some kind of DDoS attacks. Like, people can just throw your APIs with lots of requests until your servers are down and couldn't respond back to your to the requesters. How do you handle that? You can, of course, there are ways to do that through WAFs or through maybe circuit breakers or something, some conditions on the development side from the back end. Another thing is falling back. Like, if your server are getting overwhelmed with requests, what are the fallback strategy? Where do you want to divert your request instead of sending 404 to all your requests? The other thing is versioning. If we're providing an API now with specific API spec, which is the contract that we spoke about, the API may be, let's take an example from the social media. You're requesting your friend list, and it's showing you on the friend list maybe the name, maybe the birthday, and something else. Maybe later you decided to add also pictures. So this is an addition to the API. So now the API is responding with something else. But what about the initial consumers? They didn't code their code to accept pictures. Or maybe on the worst case that they removed one of the fields. So now the developers who are using version 1 are now will break. The requests will break. So how do you handle versioning? And you want to keep version 1, version 2, multiple versions of your API. Another challenge is monetization, and that should be very helpful and should be in all of our minds. How to monetize your services, especially as small companies and developers, and you want to monetize. Like, the big companies are already monetizing, but if you want to monetize your APIs, you're providing services, and you want to make revenue out of that. So how do you manage who's using what? You want to put some tiers to your APIs, like maybe a free tier, like we mentioned, maybe a basic tier, maybe a pro tier that can consume 200 requests per second, per second, or a basic tier that only limited to 10 requests per second. So those are some challenges, and to come over those challenges, we have API management. So we have front end, and we have the back end. And we need a layer between to manage those APIs. So the definition of the API management is the practice of establishing efficient, standardized process for working with APIs. Again, very fancy name, but the main idea is an intermediator between the front end and the back end. And that intermediator has policies that can define how you interact with your APIs on the back end. The main components of API management are usually three. So we have the developer portal, and that's some of the services, and we'll speak later about the services that provide API management. Some of the services have developer portals. Some of the services, they don't provide it for you, but they let you develop your own portal. So this is optional. The two main components are the management portals and the gateway. The management portal is how you configure your backends. This is where you register your APIs to the management. This is how you can define policies, like how define your tiers. What are the maybe the basic tier, the pro tier, what are the requirements for each tier, and how do you want to implement policies? And we'll speak about the policies on the next slide. In the management portal also this is where you can manage your users, manage your groups, do the connection between your API management and the backends, all your backends, whether your backends are servers consuming your stuff, or maybe functions, Azure functions or Lambda functions, or maybe containers. You need to link and let the API management know what are your backends. And the third component, which is the most important one, is the gateway. The management portal, you put all the configuration, but it needs to provision those configuration into the gateway. And the gateway is the component that receives the requests. So it has to know, okay, if I'm receiving the request from this user, what should I do? If there are policies applied into that, to this API, how can I execute those policies? How can I generate maybe blockage? How can I do transformations of the requests? We spoke about caching, like how can I do caching? All this is done through the gateway. So the gateway is like the mind of the API management. The management portal is just how you configure that mind to make it do what you're looking for. Any questions so far? Okay, cool. So we spoke about policies, and we mentioned like from the management portal, you can create some policies and manage those policies. Let the gateway manage those policies. So what are policies? Policies are just statements that you configure your gateway to do. Some of those policies could be related to flow control. So for example, we just speak about versioning, one of the challenges. So maybe you have your API version 1 and version 2. And from the URL, the gateway will understand that v1 will be sent to backend number 1, version 2 will be sent to backend version 2. So it's seamless from the front end. They don't need to specify where to go or different URLs, but the API management in between can do the flow control of those codes. Can also do, some policies can do some verifications. So maybe before sending to your backend and consuming all your resources, maybe you just want to confirm that there is a header for the API key. If there is no header, don't even send to the backend. So we're removing that. Maybe you want to make sure that in the request, there is a name field in the body. If that is not available, don't send the request, and maybe just respond directly. So the gateway will respond directly without going to your backend and consuming your resources. We spoke about authentication and authorization. That could be through like a JWT tokens. And the gateway itself can be configured to connect to an authentication service like Okta or any cloud authentication service, and it will do this authorization authentication on your behalf. So you offload this to other service. Instead of you code all these things, you offload it to the gateway so it can do this authentication authorization for you. Caching, we speak about caching. The gateway itself can do caching, so it can, instead of sending all the requests back to the backend, it understand that, okay, there is a 30 seconds cache, so all the requests coming within that 30 seconds will not go back to your backend. It will get to the gateway, and the gateway will understand, okay, well, I have cache for this for set up for 30 seconds, so I'll just respond back from my cache without going to the backend. So it's reducing the load on your backend and making the communication even faster because it doesn't need to go further than that. There are also other policies that can do transformations. For example, transforming from XML to JSON or from JSON to XML, and any other transformation, maybe just replace this header with the key, something like that. So in that case, the flow will be like that. Instead of going directly from the user or from the developer or from the UI directly to the API, everything will pass through the API gateway, and the API gateway will do some logic and analyze the request. If it's valid, verified, we have the right authentication, it will send it to the API, the backends, and on the going back from the API to the user, it can also, there are policies also that can be transformed on the other side, like maybe responding with JSON, the API, and there is a policy to respond in XML, so it will do the transformation, or it add back another header to the user to consume it. Okay, so this is all good. There are lots of API management tools that I worked with, and they're available. MuleSoft is very famous. 3Scale is one famous one. And there are also cloud versions. So we're speaking about the cloud. This is the cloud track. So why do you need to do that in the cloud? So first of all, you don't need to buy the API management as a solution. You can just pay as use. As much as you add and configure and provision APIs, this is what you pay for. Most of them has very generous free tier, so you can consume it for free, especially for your side projects. You don't need to pay for anything. Second reason is it's native integrated with other cloud services. We were just speaking about authentication and authorization. So if you're using AWS, there's something called Cognito that can handle the authentication and authorization. If you're using Azure, Active Directory can handle authentication and authorization. And it's seamless integrated. Like you don't need to write any code to do the integration between your API management and it. We just spoke about Redis and caching. So you don't need to go and implement that yourself. It can auto-scale. If there are lots of requests coming, you don't need to handle the management. And it upgrades auto for you. So you don't need to manage any of that. That's one of the reasons the cloud is great for that. As I mentioned, I work for Amazon and Azure, so I'll just give a quick comparison. It's your preference at the end, but you can use, like in AWS, for example, they treat API gateway as separate service base. So each request, you need to create another API gateway, another API request connected to it. On Azure, for example, it's one solution. So you create a big solution and you configure all your APIs within that. API gateway on Amazon, there is no developer portal. On Azure, you get the developer portal. On AWS, it's only cloud-based. So the gateway itself will be deployed in the cloud. In Azure, you can deploy it in the cloud, or you can deploy it on-prem, but that's with an extra cost. Why the solution-based will be better? You can group all your APIs into products. So instead of selling or giving your APIs one API per one API, you can group that into products. You can apply those policies into products instead of applying each policy to each separate one. If you're using with like something like API gateway, you need to apply the policy for each API. And you can manage all the users and groups from the same pane of glass. And in that case, you will have users who belongs to groups. Both users and groups can subscribe to products, and each one of the product has multiple APIs that can be configured. Some APIs can share into multiple products, and some products can share multiple APIs. So it's seamless authentication and authorization, and that will be the flow at the end. Okay, any questions before I go to the last one? Yeah. Okay. I would say always whenever you deploy your services, just use the one that you're already deploying there. Don't deploy your service in Azure and put your API management in AWS. That would be too much for latency. Okay, I know we're kind of on time. So just 3 takeaways here. Always secure your APIs. We just mentioned about the DDoS attacks. We mentioned about authentication and authorization. All these are layers to secure APIs. You don't need your APIs to be down at the end, especially when it's generating revenue for you. don't reinvent the wheel. So if there is any, don't write your own code to do the authorization and authentication. Don't write your own code to do the caching. Don't write your own code to do the flow control. If there is a free service that can help you do that, just consume it. Keep your code for other things that are more business related. And always like expand your horizon. So I know most of us are developers who just focus on our code, but take a step back, think what else you can use to help you with your code. Like we just spoke, again, I'll just take again the authorization and authentication thing. People think how to implement that, how to write the code for this, how to do it. You don't need to do that. Just take a step back. There is a service that can help you do that. Just relax. Focus on your business, core business value that you're providing. Okay. Any questions before we get connected? Okay, I think I'm connected with some of you here already. I'll be happy to connect and keep connected with you. I'm here in Dallas, so you'll see me on the meetup from time to time. I also co-host the Kubernetes meetup here in Dallas. If anyone is interested, we'll be happy to just chat with me and let's see what we can do. Thank you, guys.
disappointed there's no rubber duck on your table.
You know, I actually do have one. I should have brought it.
One that has a speaker in there, just so that way you can like play.
Yeah.
There you go.
Like, oh yeah, it's talking back.
ChatGPT logo. Run the logo. Duck.
Is that feedback from next door, or is that here? Every once in a while, I hear like a little mic sound. Okay.
Blame the other guys.
Let me know when I should get started.
I mean, it's 11:30.
Okay. All right, we'll start in another minute.
Things are just a little bit behind because the keynote ran over.
Yeah. I saw people still out there.
Oh, I mean, they're talking to people. The network session.
All right. Yeah, let's get started. I have a lot to talk through, and I'm originally from New Jersey, so I talk a little quickly. You're going to see a bunch of walls of text. Don't worry. There's a thing you can download after. It's LLMs. There's going to be a lot of text. There's really no way around that. But my name's Alec Lozarescu. I've been working in the education industry most of my career, but the AI stuff has always been kind of a outside of work passion as well as inside of work. So I found some interesting things about how we can work together with AI models. And who's heard of like the rubber duck principle, like you talk to a rubber duck? Awesome. Yeah, so for those that haven't, just the way you can go through and put together your thoughts, explain it. Sometimes you find that you actually figured out the issue or solved it. And the fun part about doing this with a language model is it talks back. So you may figure out just explaining it, but you may actually get feedback and get some interesting results back. So we're going to go through, talk about what information you should provide to a language model. And I say language model in particular, I typically use Claude Sonnet 3.5. ChatGPT works well as well. So you want a decent, powerful model to do this on, but you do have some choices there. And we're going to look at how we do a bit of a back and forth dialogue, some interesting tips on how to do that. And we're going to start with the high-level architecture, run through that a little bit, and then go to the code. And the reason we do that is because if you just ask it to write a bunch of code, you're going to pay a bunch of money for all those tokens. You're going to wait while they all kind of slowly drill down. And inevitably, you'll find out like, oh, I didn't want it to do that, or oh, I meant something else. So it's much easier to have it do a plan with you and then get to the code after you agree on the plan. And a lot of these things kind of sound similar to working with people. So it's a little bit of a weird time now. We're kind of anthropomorphizing these AI tools because they are based on language. But just things to keep in mind. If you couldn't explain it to a person, don't expect great results from the model. So one thing you can think of it is the AI model can act as your editor. And I don't mean like an editor like, oh, you have a typo, you have a grammar mistake. It's more like a development editor, where it's someone who like really understands your story, your character arcs, all of those things. And then it can give you advice if you're being inconsistent or you're missing something or they have some ideas. That's kind of how we're going to be collaborating on the high-level design. So we're not going deep. We're not asking it like, write this one method for me. We're kind of going a bit higher level. And you could do this right at the beginning, ask it to create an architecture plan based on some information you give it, or you could give it an existing plan that you have, whether it's in production or proposal. Like either way, you can still get some value out of it. The context is super important. So imagine you're hiring someone new who's going to be a software architect. Not every company is the same. There's the favorite answer of like, how do you do this? Like, well, it depends. And there's a reason for that because there's different needs each company has, different industries they're in. It's not just write me this and it'll work everywhere for every purpose. So it's not so much that there's a lot of wrong answers, but there's ways to get something that's a good fit for you, and you can provide context to the model to get a better chance at that. And it'll let you converge faster on something useful if you do that up front versus sort of go back and forth, getting like not something you need and slowly kind of knocking pieces into place. After you put in a context, you describe what you want to build. this is something you can vary in terms of how long it is. We're going to do a very quick, simple example and show how it might work. But really, the project plan and the context is setting the stage, and that I can give some advice on. What you want to build is obviously totally customized to your circumstance. And as you go through talking with the model, the thing I do is I ask it to ask me questions. Like you'll see I end with like, ask up to 5 clarifying questions. So instead of just it going off on itself and it going, oh, maybe you want to do this, or I'm going to take this approach, it can right away put some questions back at you. You'll answer them and get it in the right direction much more efficiently. You can ask for reasons, like why did it choose something? Sometimes it'll find out that it made a mistake based on some clarification. Other times you may find out that, oh, you know what, this is actually a better approach. And you can even open like a separate window, go like a little learning side quest. If there's something it tells you about that you haven't used before, you can poke at it a bit, learn a bit more about the technology, get some references to read. I find I sometimes jump out to like a Perplexity Pro instead of ChatGPT, because it also like integrates the web and gets a really good source material, including like things you can click through for details. And this last part is where it gets like a little bit fun and different than what you'd expect. So we have people at our company sometimes that challenge us, and this can be in positive ways, or it could just be kind of a little combative in meetings. But we'll just say, like, let's say there's this person, Bob, at your company, and he's been there a long time, super experienced, does a great job, but he's really, really like not interested in like doing new things. It's like, well, we've done this way for years. Like, why are we adding complexity? Why are we kind of doing all these services and interconnection points? This seems like a bad idea. Like, I don't get it. You can actually craft a persona, have the AI almost like role play this persona interacting with your design or its own design, and what it would say to them. So this is kind of a bit meta, because you've got AI playing a character talking to itself, but it's really useful because you can see what arguments you may get from people like this at your company, or just get an idea of how to be prepared and maybe adjust your design for the better. And you can make a stronger case, and it's almost like a mock debate you can practice for. And you can add a lot more personas. You can add a business person, you can add a CSO, a CIO. All of these are useful to just identify any weaknesses, things you maybe have not considered, or maybe things you did, but this lets you crisp your answer a little bit better. A little tip here, if you can use mermaid declarative diagrams, that works really well with both these models, the ChatGPT and the Claude Sonnet. And I'll show an example of what they look like, but instead of having like an image or a kind of a hand-drawn diagram, you basically put like a text-based format to describe whether it's a UML sequence diagram, a flow chart, whatever you want to do. And that's very easy for the models to understand and create for you. Or if you paste it in, it'll understand what you're looking at. And you can kind of round trip this thing between tweaks you make or tweaks the AI makes. And I like it because you can literally put it into like GitHub in your README Markdown file. It'll render inside of GitHub. If you pop it in tools like Confluence, there's a little macro, it'll render in Confluence. So you can kind of take these diagrams everywhere. And if someone's making code changes, they can update these. And you see in your code review, literally like this line changed, like, oh, they added a call from this service to that service. So really super helpful. And it's even better when working with these AI models. So just to kind of reiterate, we're going to get to some demos soon, but this is a great way to use an AI model to get early feedback. You can understand what concerns might be raised. You can get new ideas, new approaches, and you can test versions quickly. So you can get rapid iteration. And you can be ready like ahead of presenting to real people. Like this is not a substitute for like, oh, I'm just going to talk to the AI and I'm going to go build this and like I'm not going to talk to my team. But what this lets you do is get a refined version of things before you talk to people. I don't know if you've seen at your company, but places I've worked, it's become much more scheduled. It wasn't like it used to be where I just walk over to someone's office or I walk over to where the team sits and like, oh, I see they're not super busy. We'll just chat about something. Like I got to put a calendar invite. And I'm working with people in different time zones, different offices. So by the time I get to talk to someone, it might be a while. And if I could have some at least simulated feedback, it at least gets me thinking. Again, this is feedback. This is not the AI model is going to do my job and I just sort of like paste it in email and like go fishing. But this is something that will help you really get some additional insight and like clarify your own thinking by using it. So I'm going to start showing a couple things. Again, there's going to be a wall of text. There'll be a link to it, but it'll give you an idea of the type of things we can do. So the first thing is what I call the project classification. So I'll just highlight a few things. You'll see when you look at the examples later, like the full thing. But it helps to set the stage for what are you doing for this architecture? What is your goal? Are you doing this to get ready something right for production? Are you learning a new technology you want to share with your team? There's a big difference between making a POC where the focus is kind of readability and like having it easy for someone to run, and making something like production ready where it's got to be scalable, secure, all these other things that if you threw this in front of a new person just to like demo something, it'll be super confusing and a pain to run. So you gotta set that context to get something back that's fitting what you want. I also like to tell it, where do I kind of tend to go with my group? Like, do I want to build an initial system that's simpler but can expand later, or do I want to kind of do more out of the gate? Depends what your customers are looking for. Are you making an MVP, or are you for sure building something for like telecom scale? Like we know it's got to be 5 nines. Like there's no like if, ands, or buts about it. What's the load it needs to handle? I just gave it simple orders of magnitude here. So what you do is you essentially use a template like this, just pick an answer from each of the categories and make that as part of your project's context. SLA requirements, again, if you have 5 nines, you're going to have a much different, much more expensive architecture than if you have 3 nines. So the model needs to know these things to do something out of the gate that's closer to what you'd be looking for. Data loss tolerance. If you ask someone like, are you okay with losing data? The answer is no. Okay. But there is nuance to that. It costs a lot of money to add just a little bit more data tolerance. If you think about like if you're failing over to another region, if you can't have any data loss, like what's that mean? Well, that means you're probably using synchronous replication. It probably means you're a bit slower, you're spending more money. And when you tell people like, oh, that'll cost 5 times more, they're like, no, you know what, like 2 minutes is good, I'm good. So we'll jump to the organization template. So that was like the particular project. There's probably things about your organization that would be good context to add. You can definitely make your own. This is just an example. I did something simple where it's like a level 1, 2, and 3. Like how is your team's cloud capability? Like, are they used to just working in applications and having like a managed deployment system? Like in the past, it would be like Heroku style, or just push the code somewhere, auto deploys, and they don't worry too much about it. Are they somewhere in between? They're kind of aware of containerization and kind of a bit more advanced things. Or are they cloud native experts? Are they building their own platforms and patterns in the cloud for for what you're putting together. You'll have different answers based on those. Do you have any approved languages or technologies where, you know what, like we focus on Java and Python, and if you want to do something else, you got to go to some approval board. Like some people work in that place, so you might as well tell the model up front versus it going off and doing something and later like, no, actually we can't do that. Are there any disallowed technologies? Sometimes they're disallowed for regulatory reasons. Sometimes the boss had a bad experience and now no one can use it. Like whatever it might be, put it in, give it to the model. Any sort of compliance, data protection, integration standards. If you use Auth0 and you want the model to do that, if you use Stripe payments, like whatever you got in there, add it in there. So here's an example of what I was talking about for the project. So you'd go through the categories, and in your prompt, you just pick and copy it. And I didn't just copy production-ready architecture. I copied the little blurb that has a bit of detail on that, because that's what like makes sure you and the model agree on like what you mean by that. I did 100 TPS, 4 nines, 0 data loss, and level 2. And this is what we do here: Java, React, Postgres. We don't like these things for whatever reasons. We have these requirements. And now how do I use that in a prompt? So I take my sample context, which is both the project and your organization one, and I kind of use it like a template variable. And I start this off like you're an AWS solutions architect aiming to create a cloud software architecture design for a given feature. Here's the context. And I put one sentence here. I want to design a patient scheduling system, just for an example. You can put as much as you like. And then I end with this part, which is important. First of all, I tell it we're not writing any code on the stage. We're just focusing on agreeing on a design. That way it doesn't start like spinning out a bunch of files before you like understand what it's doing and why. And I ask it for a few things. I ask it for a high-level architecture, which services are suitable. I put in AWS here. You can put in whatever you want. I told it about the diagrams in that mermaid syntax, which I'll show in a little bit. Ask it about deployments and what to detail. And then I say, ask up to 5 clarifying questions before starting. And before it does anything, it gives me a bunch of questions. And they're usually pretty decent questions that are useful for kind of guiding it. So I'll go through the rest of these kind of little prompt starters, and then I'll show like the actual like conversations, and you can kind of see how it plays out. So the critique persona, like the first one we talked about, like we just called this person Bob, highly wary of new technology over the complex designs. Create a fictitious devil's advocate response for them upon seeing this design and some of the questions they've raised. For each point, determine whether criticism is valid and a better approach exists, or you can justify the existing design. So we are not saying Bob runs the company. We're not saying Bob is always right or wrong. We're asking it to make some sort of judgment to the degree, whatever degree this model can, and provide justification. And the justification is important because if it just says like yes, no, no, yes, like what do you do with that? You can follow the justification and like see if you agree or not. And it wrote this in the form of like a pretend email, which I thought was kind of fun. It says, why are we using Fargate instead of plain EC2? We already know how to manage EC2. And the model, this is the model responding to the fictitious email. So this is why it gets kind of meta. It says, this criticism as merit is only partially valid. So it talks about Fargate eliminates capacity planning. It doesn't really cost more. And it has like a lot of managed features. And then Bob was like, oh, this was a different example. Like it was like a reporting system. And it was like WebSockets for report completion, that's overkill. Why not just have the browser poll? And in this case, the model is like, you know what, that's valid. Simple polling is fine for the type of reporting to do. I'll update the design. Why Redis? Just for session state. Like, you know what, it's not a busy app. We can just throw it in Postgres. So it kind of goes through and like you can agree or disagree. It can adjust the design for you. But at least you kind of heard and have things to think about. Critique persona 2, I put like a CIO for security, looking for compliance gaps and disaster recovery business continuity posture. And it said, this doesn't invalidate earlier constraints, but should be considered alongside them. And it says, your design shows no encryption strategy. Most people's POC designs don't always put that in, even though we typically do it. But it doesn't hurt to like throw it in. So the system goes, you know what, you're right. I'll add RDS encryption. I'll add this and that. I see no audit trails. Oh, that's a good one. Yeah, we should probably add that. So you can see how this approach can be pretty interesting to get more information about what people may expect. And you may decide, like, you know what, that's like TMI or TBD. Like, I don't want to make a 30-page presentation. But at least you have like an answer ready. Like, if someone brings it up, you have something that you've thought about. So you're not kind of caught off guard. And this last one was fun. So I made it like a business persona where it's someone who's always talking with customers. Maybe they're in sales or marketing. Maybe they're the CEO of a startup. And they're sponsoring the project, but they're concerned about the cost and timeline and like, what is the customer value? And this part in yellow, I added in because the model started telling this person like, oh, this part will be phase 1 done in 3 weeks. I'm like, whoa, whoa, whoa. Like, what are you doing? This model's like promising on behalf of teams on some high level design. Like, no. So I added this so that it didn't even like give nonsense like that. And then it goes through for each step and like, what do we do? Explains it in kind of more simple terms. What's the business value of it? And even like a customer message, like we can generate reports simultaneously without impacting performance. Like that's why we're doing this upgrade for you. We're adding more reliability. We're using auto scaling so that it's more cost efficient. So it doesn't cost as much to run, but when you need it, it'll be there. Like all these things are in here. So handy stuff. And I'll write the last prompt here, and then I'll show the mermaid diagrams and some example conversations. So let's say we went back and forth this model. We got a plan that we agree on, and we wanted to write some sample code. Again, this is sample code. It's not like guaranteed to run, but I give it a bit of a preamble. You're a senior DevOps engineer area, solutions architect, create a CDK v2 TypeScript project to implement this architecture plan. That's kind of a mouthful, but so CDK is just a deployment framework on Amazon that lets you do infrastructure as code. And it's a nice way to deploy things because instead of clicking around the console and making things, it'll create it for you, it'll destroy it, it'll update it. It could be a little challenging to learn sometimes. I found this a great way to kind of teach people like the general idea of it. And if you create it with the AI model, it can often be faster and easier to just do this automation than have someone click it manually like, oh, they did it on the dev site, they did it on this other site. Like by the time you're done, like, you know, we probably should automate it in the first place. And then you can include your general guidelines. I put just one. Clearly, you can put a bunch more. I find I have to tell it this every time, like create a list of constants at the top of files rather than magic strings strewn within them. This thing seems to love like just putting things in strings, and I want to see what I can configure. You could tell it create an env file, like whatever is kind of your typical practices. I have like long ones that I customize based on what I'm doing. Then you paste in the plan, and I put in some example follow-up questions. Like this thing just started rolling. I'm like, hold on. What's the folder structure? Like, where are all these files supposed to live? And another follow-up. Okay, this thing's like giving me a permission error. Add some instructions for creating the IAM user and get that going. So I'll switch over to the example. So this is a conversation with Claude Sonnet 3.5. And you can see I have my little preamble here. I pasted in the project classification that I showed. And at the end, ask up to 5 clarifying questions. And it asked me some questions. What are our main personas? Patients, healthcare providers, admin staff. any integration requirements, what's data retention policy, performance requirements, do you need real-time notifications? Like, oh, these are pretty good questions. So I gave it answers to all of them. And then it created a high-level diagram. And we can pop this up, and we can see this is in that mermaid format, where it's a flow chart. It's got some subgraphs, and it's got all these connection points. If you're not familiar with this, it could be kind of a pain to create, but once it's there, it's pretty easy to tweak. Like if you're like, oh, I just want to add one more line here, one more service, it's much easier to just add on than make these from scratch. And when you preview it, you can actually see what this looks like. And this will actually render nicely in GitHub. It goes on, talks about key components for the front end, what it thinks it should do, Cloud Front End S3, WAF, an API gateway, ECS Fargate. So it goes on and on. I'll show another example. So this was the report generation one. And this was where I gave it a little bit more free-flowing stuff before I had a template, but I covered some of the same things like, oh, we're just 6 people, we're working Java and Python, we use Datadog, aim for production ready, this is how many reports we're doing. Then I continue with not writing any code at this stage and the rest of it. Ask me why 5 questions. It makes a sequence diagram. So you can see what's happening here. It's checking a cache in Redis. So a pretty handy way to explain things. I ask a follow-up, like how is the browser notified for long-running reports? CloudFormation's hard for us. Is there something easier? And it goes and talks about, okay, let's do this with WebSockets. It even starts writing code even though I told it not to. Sometimes these things don't listen.
They don't have the best memory.
Right. They also don't have the best memory. That's another reason why you want to get as much up front. Because if you keep going back and forth, by the time you're done, it forgot something you already told it, and it's frustrating. So it talks about there's like a WebSocket or a server sent events approach. This is where I would go on a side quest and like, oh, what's the difference between WebSocket and server sent events? Let me open another window and like learn about that. And here I put the personas, like it's reviewed by the CIO and what it wrote back. And back to that mermaid chart. So if you go to mermaid.live, you can paste that in and see the rendering. And you can just edit this and it starts syncing up to it. So very neat way to show things. So running close to time now, so I'll just pop back to the final slide. So I got a QR code, also got a link, botsandai.com/126.html. That's today's date, 12/6. So I have a link to that document where I show the prompts and other things you can look at. You can take a look at that. This is very much something for you to customize. It's a good start, but it's something you can look at. And I also run meetup events. I've been doing events since, 2016. So ran quite a lot of events, educational events. So if you're interested in more AI talks, I have people from other companies talk. Sometimes I talk. Definitely check it out. We have a talk on December 17th also about AI and making your developers leaders at every level.
Is it here in the Metro?
It's online.
Oh, it's on.
So it's everywhere.
Oh, okay.
Yes, go ahead.
So you mentioned some of the memory issues that it has where it forgets some commands. At what point, I know sometimes when I start going back and forth, I look much better than changing. But after a while, the conversation starts going in the wrong direction and I just start over.
Right.
How do you know when you start getting less usefulness from that one session and it's time to move to a different session? And how do you bring over what useful is from the previous context?
Yeah, that's a great question. There's no hard and fast rule because they keep changing these models. and they do a combination of sending a lot of stuff versus some summarizing, and the summarizing is hit or miss on their back end. So if I find I've got like a neat diagram and enough context, I will sometimes pop the instructions and the diagram into a new window and then start iterating there. I ask it, summarize this, create a document that explains your design philosophy, and then I can just pop all those over to a new spot and try again. And the nice thing about having these documents is you can give them your developers. I find writing documentation is much easier where I have a head start or rough draft. I can show it a bunch of things, create the documentation, or if I start a design directly, it has it from the start, and you get much better like next steps on it by having some documentation for about the reasons why you did things and what the components are and all of that. Yeah.
Have you started using the projects with the team? I haven't.
I've used it a little bit. I haven't yet found the breaking points of those. It seems to tell you it'll do more, but yeah, it's definitely something to experiment with further. I haven't got a lot of experience. I tried one quick thing with it. All right, thanks everyone.
My one
We're live?
Yeah.
We are live. Okay. Start my timer. Hello, everyone. Welcome. Yeah, everyone is well eaten. You've had your lunch, right? You're ready. You're not going to take a nap on me. Did you get your Red Bulls? No? Okay. All right. So this is actually like 45 minutes worth of material that I'm going to condense down to about 25 minutes. So I'm going to try to go a little bit fast here, but I'll stick around at the end for any questions that you might have. We're going to talk about optimizing AI in several ways: efficiency, relevance, and cost savings. My name is Jesse Hall. I'm a staff developer advocate at MongoDB. You might also know me from YouTube as Code Stacker. If you haven't heard of my YouTube channel, you can go ahead and subscribe. I'd appreciate it. Now, even though I do work for MongoDB, this talk is not about MongoDB. It is technology agnostic. So you should be able to use this in whatever stack you're using. So brief agenda, but we're going to skip past that. We're just going to dive right in. So you've heard of this thing called GPTs, generative pre-trained transformers. These large language models perform a variety of tasks, from natural language processing, content generation, and even some forms of common sense reasoning. And so these are really the brains that make our AI applications smart. This is the underlying technology for that. But there is a catch. These GPTs, they have limitations. The main limitation is their static knowledge base. They only know what they were trained on. And so that is one of the issues. We know that there are some integrations now that allow them to search the internet to find more relevant information. But how do we know that that information that they're finding is relevant? They can also hallucinate. They just make things up sometimes. So how can we minimize that? And they can't access our proprietary data, our domain-specific data, and that is a really big limitation. And so how can we fix these LLMs? Because creating a new LLM from scratch is very not cost-effective, right? It's very expensive. So how can we fix that? That is where RAG comes in, retrieval augmented generation. You've probably heard this in a couple of other talks here earlier today. We're going to quickly kind of get an overview of what RAG is so that we can understand what we're trying to optimize for. And so let's go straight into the first thing that we need to understand about RAG is our vectors. So we have this vector here, a quick brown fox. That text equals this array of numbers, these floating point numbers. Those are vectors, vector embeddings. So these vectors, they are a numerical representation of data. They are basically just an array of numbers, right? And these are coordinates in an n-dimensional space, where n equals the number of items that we have in that array, right? So however many numbers we have, that's how many dimensions we have. And you might also see these referred to as vector embeddings or just embeddings. So here is a real-life example of vectors in use. So you go to Home Depot, you're looking for light bulbs, you ask one of the employees there, where can I find light bulbs? They say, go to aisle 15, bay 30, right? So that is a 2D vector in real life. And also notice that all of the light bulbs are kind of strategically placed near each other so that they're easy to find. It's exactly how a vector database works, and exactly how vector embeddings work. They are strategically placed in a way that's easy to find using vectors. And so again, what makes them so special? Vectors allow semantic search, similarity search. And so they find things that are contextually relevant and not just keyword matches. And then these data sources, they are not limited to just text. You can create vector embeddings for text, images, audio, video, and so on. So these can all be converted to vectors, but how do we do that? How do we go about converting these to vectors? We use this thing called an encoder. And an encoder defines how the information is going to be organized in that virtual space. And there's different types of encoders. So there's encoders for text, for images, video, and so on. These are, you'll also hear them referred to as embedding models. So these are LLM models that are meant specifically to create these embeddings. There's going to be some QR codes throughout this, so if you have your cameras ready, you want to learn more about choosing the best embedding model for your LLM application. This you can dive a little bit deeper here to learn more about choosing, because there's so many different embedding models out there. All right, I'll just go back. I see a couple of cameras still up. I'll wait for the cameras to go down, and then here we go. All right, so what does this look like in practice? So we've got our private data, our custom data, whatever that might be, and then we split that data. If it's a long article, we have to split that down into chunks, and then we create embeddings from those chunks, and we store those chunks in our vector database. And again, this could be text data, it could be images, it could be video, and so on. And so this actually, this looks simple, but there's actually a lot to this. There are, in fact, chunking strategies. So you have to pick the right embedding model, but you also have to figure out what is the correct chunking strategy for whatever it is you're creating embeddings for. So here's another resource on how to go about choosing the right chunking strategy for your LLM application. All right, I'll give it just one more second, and then here's the rest of that. So we've got all of our embeddings in our vector database now. We can now accept user queries. So the user has a prompt, and what we have to do first with their prompt is create vector embeddings for their prompt. We want to put their prompt in that same virtual space as our custom data. So we create embeddings for their prompt. We figure out, we send that to our knowledge base to use vector search to find the most relevant chunks from our knowledge base, and then that outputs the chunks, and then we send that to the LLM. So we're kind of intercepting their prompt. We're intercepting their prompt, we're adding some extra context to it, and then we're sending it to the LLM to answer the question. And so that is RAG right there in a nutshell. Let's talk a little bit about search and retrieval. So search and retrieval is very similar to RAG. This is a normal RAG pipeline at the top. You've got your database, and you're searching for the similar information, and then sending that to the LLM. How can we improve this RAG pipeline? So the first thing that we could do is we could add a filtering stage. So what if we had extra metadata in our database that allows us to define which chunks we know are relevant to this query and which chunks aren't? And if we could filter out a bunch of chunks before even going into vector search, that would save us a lot of time, and it would result in lower latency and cost savings as well. So this is one of the times where I'll talk about MongoDB. It's a great general purpose database for saving that metadata alongside your embeddings in the same database, and not having to go back and forth between an operational database and a dedicated vector database. So eliminates a lot of that need there. So the next step, we go on to the regular vector search, just like we do above, but let's add to that. Let's add a scoring step. So the scoring step, we could incorporate maybe some user feedback. We could rescore these chunks to optimize for certain keywords. And then after that, we could add an ordering stage. And so an ordering stage, in that stage, we could re-rank, maybe using a re-ranking model. Because we have seen, there have been some white papers written about LLM's context windows. They tend to concentrate on the top of the context window. So the bits that we send it first, it concentrates more on that and not so much at the rest of it. So we want the most important information to be at the top of the context window. So let's take a look at each of these stages of this 4-stage RAG system. You're not going to see this 4-stage RAG system anywhere else. This first stage is the filtering stage. Again, if we have some metadata that we can filter out certain chunks before we send that to the vector database, you can see here that a filtered vector search is going to be more accurate, and it's also going to be computationally less of a load, because we're not sending all of the chunks to the vector search in order to search through. And here is an example. Here's a real-world use case. So the yellow query vector, that is the user's query and the vector similarity to the documents around it, right? And so let's say that we have a movie database. So the user wants to find movies that have an IMDb rating greater than 7. And they also want to return the top 2 results. That's what K is. K is returning the top 2 results. So in our metadata, in our database, we have IMDb rating as a field that we can filter. And we say, only send embedding chunks that have a filter greater than 7, and then send that to the vector database. So that's going to result in those 2 being returned because they have an IMDb rating greater than 7, and they are the closest to that user's prompt, to their query. And so again, that is going to be less computational load and more accurate, and less latency as well. So there are a couple of different search methodologies. We have talked about vector search in the context of RAG, but there are other search methodologies. One of them is lexical search or keyword-based search. Now, usually, in almost every RAG situation, you're going to use vector search. But let's understand to reorder them so that the LLM has the most relevant information at the top of the context window. So a re-ranked hybrid search, again, is going to be more accurate, but again, more computational load. So here's what that looks like. We take our results in whatever order the LLM decided to give them to us because it doesn't really know what order we want them in. And we send it through another LLM model that is specifically designed for re-ranking. So these models actually calculate the relevance between query document pairs, and they're able to tell which ones are the most accurate. And so now we have that 4-stage RAG system. We've gone from a regular RAG system, which is very accurate, sure, but we've taken it to a much more accurate system now through all of these different steps there. So let's move on now to the saving money part. So we've made it more accurate. How can we, in production, save money? So we're going to talk about 2 things. We're going to talk about prompt compression and vector quantization. So prompt compression, we have many different prompting strategies. Prompt engineering, that's a thing, right? So most of these prompts that you look at, they're like walls of text, huge amounts of text that we're sending to the LLMs. And because of this, the context windows of LLMs have continued to grow and grow and grow. But tokens cost money. It costs money to send all of that text to the LLM. It takes the time to process it, and then it has to return the results from that. So we actually have seen prompts that have 100,000 tokens, even 1 million tokens. It's like passing an entire novel to the LLM in one pass, and that's not very efficient, especially when you're using it through an API call. And it can become very expensive sending all of that over the wire. And so what we have here is 500,000 tokens that costs in this input, and then we're outputting 4,000 tokens. Very large context windows. That's kind of the norm now, but how can we change that? So we're going to talk about prompt compression. So this is the process of reducing the number of tokens that we are passing into the LLM. So how do we do that? Our goal is to have the same output. We want to, whatever the uncompressed prompt is and whatever the output is, we want the compressed prompt to produce that same result. And so here's an example. So we have the original text at the top and then the compressed text. You can see that the compressed text has the essence of the original text. It's just using less words. And so, we do have to be careful here. Too much compression is going to result in less accurate results. So this is just one of those dials that we have that can help us save some money there. And so what we can see here is we can go from a prompt that is 50,000 tokens, and the output is going to be 4,000 tokens. We could compress that down to 10,000 tokens, and we're still going to get that same prompt. And again, this is one of those things that you just kind of have to test in your environment and see how much compression is too much and how much is just enough. And so for that, in evaluating your applications, I've got another resource here for you to help you evaluate your LLM applications and to see, making sure that you're as accurate as possible, but without turning too many dials too high, right? All right, wait one more second for the phones to go down. All right, so the last thing that we're going to talk about here for money savings is the reduced representation vector quantization. That's fun to say. This is basically math. This is a mathematical way to reduce the size of embeddings on disk and in memory. And so prompt compression helps us save money when we're interacting with the LLMs. Vector quantization helps us save money when we're storing those vectors and using them on our servers. And so if we look at this, in the memory requirements for indexing these embeddings. If you're using an embedding model that is 1,536 dimensions, that one embedding is going to take up 6 kilobytes of RAM. If you're using 768, that's going to be 3 kilobytes of RAM. Scale that up. What does that look like? If you're using the 10 million, if you're storing 10 million Gecko vectors, that is going to be about 30 gigabytes of RAM. If you're storing 10 million 1536 dimensions, that is 60 gigabytes of RAM. It goes up 400 for that one. And can you imagine 800 gigabytes of RAM needed for 130 million 1536 dimension embeddings? It's like it ramps up pretty quickly. I mean, I don't know who's running a server that big. So you have to optimize for these things. So how does quantization work? What does it do? How does it actually work? So we have a quick brown fox here. In our array, we have these 32-bit floating point numbers, right? So basically, quantization just converts it from floating point to integer. It's kind of like taking this image here. We want to be able to represent this image with less data, using less data, but still recognize what is in the image. We could do that by changing it to grayscale. We don't need the color information, so we can make the size smaller, but we can still tell that that's a cute puppy. So it's kind of like that. We take a quick brown fox and we go from floating point to integer. And so there's a couple of different types of quantization. So there's scalar quantization, which takes the minimum and the maximum values in your embeddings, and then it creates evenly sized buckets, and then it maps each one into a bucket. And this is kind of what that looks like. So we've got the minimum and the maximum in our embeddings. We create our buckets, our bins, and then we just map each one into a bin. And we keep repeating that process until we have our scalar quantized vectors. Another version of this is binary quantization. So this one is much more dramatic. We're going from floating point to binary, a 0 or a 1. And so in this one, we take the median value, and if it's above that, it's a 1. If it's below that, it's a 0. So pretty simple process there. We just kind of go through here and assign 0s and 1s. But take a minute here. Like we just went from floating point 32 bits, and so we have significantly reduced the information that we have here, right? Floating point number is going to represent a lot more information than a 0 or a 1, right? And so we do want to recognize that we are losing information. But if you think about this, you're starting with 1,536 dimensions. In most cases, you probably don't need the full fidelity of those vectors in your use case. So the question is binary quantization too much for you? And if it is, use scalar quantization. Either way, we have to find a way to reduce the size of these vectors, these embeddings on disk and in memory, specifically in memory. This is also going to improve latency because it's going to be quicker to process as well because we're reducing the size again. So that is the end of it. So there's more to RAG than just a nearest neighbor search. You should filter using metadata to help reduce the computational load. And then full text search also plays a role in RAG. It can help with accuracy. Use a re-ranking model to make sure that you have the most relevant information at the top of your context window. Make sure that you're not compressing too much. And then quantization can make you rich, or not really, just save you some money. Yeah. Okay, so last one, if you want to see what example of an AI stack looks like, this example doesn't include MongoDB, of course, but and if you want to connect with me, I'm CodeStacker everywhere. So thank you. Sorry for talking so fast, too. I had 2 minutes left. I have 2 minutes for questions if you want.
I think it probably is, but just for the sake of, do you think it's feasible for an LLM to a single LLM to do all these stages like on its own?
A single, no, because each one is really designed for a specific use case. Like it was made for that use case, and so you need an LLM to answer a question. You need an LLM to like specifically re-rank. You need a specific one to do the embeddings. And if you look at how many different models there are out there, and there's so many different use cases, right? So again, there's one of those resources to help you choose the right embedding model or the right model for your use case. I don't think there's ever going to be one LLM to rule them all, though. They're specifically trained for specific things.
Yeah. So the one with actual brain using the AI as a tool.
Mm-hmm.
Okay.
Yeah. Any other questions? Yeah. Yeah, so if you have, let's say you have a documentation website, you actually need to, in your testing phase, and that's in one of the articles, come up with like 100 questions and answers that you should return, right? And then start dialing your compression and your quantization dials and all those things until you start getting bad answers, and then turn it back up until you start getting good answers again. Yeah, so you have to come up with some predefined questions and answers so that you have some testing, a way to know that it's giving you the right answers. Yeah. All right, thank you all. If you have any other questions, I'll stick around for a bit.
Yeah. Why?
Can you turn your mic on your computer?
Yeah. I thought it was off.
You just turn this off. Got it.
It is muted.
On your computer. Yeah.
I was in here earlier.
Try it again.
Mm-hmm.
They were having some feedback. Oh, yeah, I was on the job. Yeah, they did the diamond maybe. Yeah, that was Let's drag their job. That sounds cool. Sure, why not?
As you can see right there, it's muted.
Yes.
It's this.
You know.
I think it is. I don't know. I can stay away from it. It's not a big deal.
No, it's fine. It's good.
I gotta get my mouse up too while we're at it. That'll make life easier.
It's good.
But you can mute everything. It's, not a big deal.
Is that the camera on now? Yeah, it's on.
Because if we mute my speaker, that might be what it is. If we mute the speaker, then is it hear me now okay over there?
Yeah.
Okay.
Seems okay.
And how much time do we have? Oh, I'm running, guys. All right. Hello, guys. All right, this is a talk I've done one time before, and it ran really fast. So for a 25-minute talk, we ought to be okay because they gave me 45 minutes. So impact of testing on a DevOps pipeline, easy enough. I'm Bob Fornell. I'm easy enough to find. I didn't put my links on my deck. I will soon because they seem very popular. But let's start with what is DevOps. Pretty straightforward to me because I work with it all day long. Okay, developer operations is a combination. So it's a way for us to get our code out eventually to production, plain and simple. Okay. As you see here, it's an infinite loop because this is something we do over and over and over again, right? In a perfect world, this is the way it works. This separates that throw it over the wall. I'm working with a company right now that has an IT department. And when I'm going to get it to production, guess what? I got to schedule a meeting with these guys. And they got to come on. And my code goes in and they got to click a button. And 10 minutes later, my code's in production. Then we go take a look at it to make sure it's working right. That's throwing it over the wall, right? Somebody else is controlling getting it there. DevOps kind of takes that away normally if it's done right. Okay. So a lot of things I'm talking about here aren't normal day-to-day operations at some companies, but there are companies where this works very, very smoothly. Okay. In the mix of this, we'll talk about something like what is Agile. Okay. How many have heard about Agile? Okay. Know what it is in depth? Couple. Okay. I'm reasonable at it. My Scrum Master is very, very good at it. Those kind of folks, they love this stuff. They love playing with this stuff, right? What is it? It's a way of focusing people and working on things and talking to people. And it really does work well when you're allowed to let it work well, right? When you're given that environment. But the same is said for DevOps as well. Okay. But getting more into the meat of what we're going to talk about here is what is continuous testing. Okay, so we talk about continuous integration, continuous delivery, CI/CD, right? DevOps, these nice little short terms. We like our short terms. But continuous testing is testing throughout that life cycle. And I can see the edge of my deck is a little off there, but I'm not going to fix that now. Okay. But continuous testing is about that responsibility to create something of quality, right? To create something that you're comfortable releasing. Right? One of the first companies I worked with, continuous testing was not something we did. Continuous testing was, I gave the code to my boss. How far can I walk over here? All right. Whoa, let me get back in the camera. There we go. Okay. I'm going to walk this way, not that way. Got it. At this company, release was I zipped up the code and I gave it to my boss and he FTP'd it up to the server and then he hopped on his computer and he poked at it and said, this works right or this doesn't. No, I don't know about you, but I don't count that as continuous testing. Okay? When I talked about possibly writing unit tests, I go, we don't have time for that. Okay. I left the job after 6 years because I spent 85% of my time, I calculated this, fixing bugs in code I'd written in the last 6 years. Okay, frustrating. I don't want to look at the same code. I want to write new stuff. I want to create things, build things, right? Not tweak a little pixel. Tweaking a little pixel is fine when you're getting that release out the door, okay? Continuous testing was the next job I had, where I wrote a scripting language, okay? And I wrote it. I got it working. I mean, this is mirrored something running on a mainframe. It was really kind of cool to do, but it's 180,000 lines of code. It was really bad 180,000 lines of code. And I said, I need to test this. I need to rewrite it and test it properly. And amazingly, I found out I'm at the right company, Leading Edge. It's where I work there in Columbus, Ohio. Most of you probably never heard of the company, and that's fine. But one of the owners of the company said, okay, whatever you need to do, that's the right thing. Immediately knew I was at the right place, right? So I rebuilt this thing, I put tests against it, and I was comfortable pushing 180,000 lines of code first time into production. I was comfortable demoing that for the CEO of the company just before we released it. It went the first year and a half and had 3 reported bugs. 2 of those were missed requirements, so 1 bug in 18 months. Properly tested code, okay? Yes, it's worth applause. It really is. Okay, so continuous testing adds to that because there's more to it than just that unit test, integration test, and things like that. We're talking about DevOps, continuous testing. What does this mean in DevOps? Okay, early detection of defects. When I write unit tests, okay, we have this nice new thing that came out recently called TypeScript, right? What does it do? It highlights things you might have problems with in your code. That probably knocks out about half the problems you're going to have right off the bat before you have them. That's cool. Still leaves 50%. When I'm writing tests, what I've found over time, and I track numbers on this stuff, is that I'm capturing probably 9 out of the 10 bugs that would normally get to production. Just when I write my unit test. I'm writing a unit test going, hey, I should get this as a result. This is what I expect. And I run it and it fails because that code doesn't do exactly what I expected it to do. It's a little off in one scenario. Tweak the code, right? Rerun it, make sure it's doing what I expect it to do. Check that test again, okay? Faster release cycles, right? How many of you sat on a release where you had to revert it back, right? Yeah, okay. Let's be honest, they suck, right? I was sat on one the other day. It took us 3 hours to back one out. Okay, getting it in there was fine. It took us 15 minutes. Getting it out was a whole different story. I was the release manager on that one. I wasn't the one that wrote the code, thankfully. Okay, improved collaboration, developers, operations working together, not isolated in these little castles. Okay, enhanced test coverage, not just the unit test, integration test, end-to-end test, QA tests. I mean, this is the test pyramid. How many have seen the test pyramid, right? Well, a couple. If you haven't seen it, look it up. It's not hard to find, okay? Test pyramids, cool stuff. Some of the strategies. Agile testing development, to automate as many manual processes as possible. I have one right now that we're debating. Do we put it in a pipeline? Okay, I've got a website. We pushed that website up, the same one we had to revert back out. We had to revert back out 5 sites. My question was, did we have to? Because we found a flaw on one page, we reverted out all 5 pushes to production. So what I did was I said, okay, Mike was the one that found this flaw. I'm going to write an automated tool to do what Mike did. Only I want to do it on about, I don't know, 100 pages. Right? We got cool QA tools you could do this with. Our QA was like screaming at me and has been for 3 weeks because I wrote something that's QA related. We'll figure that one out when we get there, right? But here's what happened. The next 2 releases, I captured all my screenshots of what it looked like before we released on about 200 pages. And within 16 seconds after the release, I had all the screenshots of what it looked like now. And Playwright said, hey, this is what they look like right next to each other. Here's the ones that had differences. And I manually went in and I said, okay, that's a difference we can accept. That's a difference. I mean, some of them were just really, really minor, like 1 or 2 pixel tweaks. But there were a couple where like the header changed. I said, hey, look, the header changed. And I slid it across. I showed them what it was. And business goes, that's expected. Part of this was changing the header. Okay. So the next 20 times I saw changing the header, I was okay with that, right? So we automated what was manual prior. Okay, equal responsibility for quality and success on the project. Okay, I am as responsible as that QA in doing that. I saw somewhere we can improve. She's welcome to take over the code. Okay with that too. Okay. Whole team, including developers, testers, operations. Everybody needs a test. Everybody's responsible for that, right? I probably shouldn't be QA testing my code. Shouldn't be. Depends on the scenario. I mean, if all of our QA are out sick the same day, okay, maybe. Rather not do that, but we'll figure it out. Testing is done continuously. Here's the interesting one. Early, often, and after it gets into production. It's amazing how often that one gets missed. Okay? You want to do it early, you want to do it often. So when I'm testing when I push into dev, I'm testing when I push into QA, I'm testing when I push into UAT, over and over and over again. All those layers get run each time. Okay? And then it hits production. So your odds of having a flaw when you get there are significantly lower. Okay? Implementation, shift left, testing. You're shifting left, you're pushing it earlier, closer to when the code is written. Okay, when I wrote that scripting language, when I tested that scripting language, it was integration tests as well, because I needed to know that this part of the scripting language and this part work together, right? I didn't want to wait till QA was testing that to find out they work together. Every time I had a flaw in the system, I was building unit tests, integration tests over and over and over again, layers of these. Okay, continuous development, continuous integration. This is the pipeline stuff that we normally talk about. Okay, there are pros to continuous testing, quick feedback, fast delivery, handling risks. We've talked about a lot of that multiple times here. Here's the fun one. What are the cons? Okay, the cons of continuous testing. Netflix, what do? Anybody heard how Netflix gets code into production? Okay, they go through all of this. They've got a beautiful CI/CD pipeline. And when they release code to production, 90% of us are getting normal code. There's a small 10% that gets potentially buggy code. Right? If you ever had Netflix glitch on you, you're probably in that 10% at that point, right? And what they do is they give it out to 10% and it might run for an hour, maybe 10 minutes. I don't know what the window is. But if it's successful and they're not getting reported errors, they stage it up to 20. They go through a wait time again and they then stage it up and stage it up, and stage it up. So if it has a problem, it stages all the way back to 0. This is automated. There's no human being touching that saying, oh, we're ready to move to the next level. Right? If it starts having problems, if users are reporting problems, they back it out automatically. Right? So bugs in production. Is it possible to get bugs in production with continuous integration, continuous delivery? Yes, it's possible. Okay? And they tend to be the harder ones to find. Okay? Loss of customers. Hey, if you're in that 10% window and Netflix glitched really badly while you're watching, I don't know, a boxing match recently, right? That they had some real problems with. Do you think they lost a few customers? Yeah, okay. That kind of a release cycle, potentially, if that bug gets there, could lose customers. Tech limitations. Okay, your organization has to be able to support more of an infrastructure, has to be more comfortable with supporting that, okay? But you have to have that tech ability to do it too. It takes time to build that up. You know, I'll be honest, I'm not gonna sit down and build what Netflix has built. Right? I mean, that probably took an entire team of engineers, probably months, if not years, to put all that together. They're probably still tweaking it today. Budget constraints, right? The organization I work with, we have about 70 people that work at Leading Edge. We don't have enough money to build what Netflix built. Flat out, we don't have that budget, okay? Where should it be done? Well, where does it occur? It occurs where, well, everywhere. Right? Here and here and here and here. Yeah, I forgot that's a funny slide. Okay.
The arrow on there pointing at plan. Don't you're not saying the test and release. No, man, that doesn't sound right.
Honestly, that's probably my mistake. Yeah, I had the original in an image. I'll go fix that one. A bug in my image, yes. So thank you for finding that. This is only the second time I've done this one, so perfect. Thank you. All right, where are we? Okay. So I had a question come up when I gave this last talk that stopped me in my tracks. Okay, I put this whole talk together. We're all excited about talking in front of this group of DevOps folks new to the industry in Columbus, Ohio. I got a room probably about twice the number of people in this one. I mean, young people really eager for this stuff. And this hand pops up and goes, well, how do you test the pipeline? And that stopped me because I work in pipelines all day long. I mean, it's a significant portion of what I do in my day-to-day processes. And I never thought about that. And testing in the pipeline. Right now I'm working with Azure, and I know AWS has it, and I believe Google has it, but you can lint your Terraform, your file that you're using, your YAML, whatever it is. So linting, just like you do with your code, checking your syntax to make sure it's right. You can run a pre-test. I can run this in a way that just tests. Is it going to bomb out and fail on something as I try and push it to production or push it into, let's say, the dev environment? So I can pre-test it, okay? It still fails a lot of times when I push it up there because there are environmental differences between my machine and theirs. It works on my machine a lot, okay? There are automated tools. I have not gotten a chance to test those because it's only been about 2 months since I gave this talk the first time. But I hear really good things about them. I want to test things like, does my API actually respond the way I expect it to without having to go back and run my sanity checks? I've got about 3 or 4 sanity checks that I can run real quick to tell if everything's spun up correctly. I need to automate those. This one simple question got me realizing I missed a part of this, right? We should be testing everything. Integration is not necessarily just software to software within that little piece of code you're writing in that front-end application or back-end, right? It could be between this system and this system. The current one I'm working on, I've got an application in Azure that reaches out to the API endpoint of Cloudflare and changes things. I need some type of test between there to make sure that works the way I expect it to, right? That's a different layer of integration, okay? We talk about Netflix. 2008, they had database corruption. They couldn't ship DVDs, this is 2008, for 3 days. Who knew they started with hard physical CDs, DVDs? All right, good part of the crowd, awesome. Last crowd, they stared at me. Okay, these were like high school or college students. They stared at me. It's like, oh yeah, they used to ship DVDs, right? I mean, and you ship it back, and it was a very small charge. It was really cool. Well, because of that database corruption, they couldn't ship for 3 days. Okay, their migration to AWS to doing what they do today took them 7 years. Okay, that's a big deal, right? They wanted to be prepared for any unforeseen errors, which is where you see this up here, where we talk about, what could cause the worst damage. When they had the whole boxing thing recently, I guarantee you, they're going back and looking at how they test things. Okay, they've got Chaos Monkey, the Simian Army. They've got these things. Think about what a monkey would do coming in and playing with your code, right? He's gonna batter the living daylights out of it. Yes. Absolutely, yes. This is what they use, yes. They have software out there that intentionally breaks things to see how their system responds. And if it doesn't respond correctly, it reverts that break and tells somebody, hey, you got to go fix something over here. It didn't respond correctly. It didn't fail correctly, okay? Respond to that failure. Testing methodology. Shift left talked about that earlier in the software lifecycle. The earlier you can get the testing in, I guarantee you, the better. If you're not doing testing now, you should be. Okay. If you need someone to help you advocate with that company, I've done it with folks I've met with at conferences before. We get together, we chat about what they're doing, and if they need me to come in and talk to a team, to a manager, whoever, I've done that too to help folks out. Testing is a high priority, and I'm actually known in Columbus for being the non-QA tester that comes into the. I help run the QA conference out there. Okay, shifting right testing. We have to do it at the end of that life cycle when the code is getting out there into the production environment, right? User testing, performance testing, fail tolerance, fault tolerance. Blah, I wrote that wrong. I have FAILT. How's that in my notes? Functionality. Okay, we need smoke testing, critical paths. Okay, if you haven't heard of what smoke testing is. Unit and component level testing, okay? Small scale stress tests. More on the methodologies, integration messages testing, collaboration over scenarios, performance testing, overall solution, functional testing, experience versus expectation, right? I expect users to use my code a certain way. I guarantee you they're going to use it differently, right? We have to try and predict that if we can, and if we can't, add it to it once you realize what that experience is, okay? Regression testing. Do we have stable performance, functionality, dependencies over time? Okay, that's where it gets really interesting, because how do you capture states of this throughout? User acceptance testing, real world situations by a subset of real users. That's when you find out, oh, I'm missing some tests because they do things I didn't expect. Okay, they scare me on that. Sorry?
Regression testing.
Regression testing. Did I spell it wrong?
Yeah.
Regressed. Wow. Okay. Awesome. We're 2 for 2 today. All right.
User acceptance testing right now.
User acceptance testing. I love it, guys. All right. Best practices. Test early, test often. Eliminate risk with CI/CD. Quick feedback on quality. Reduce opportunity for new errors. Okay. Pair testing programming is something that I throw into here because this tests, challenges in our automation when you're pair programming. Okay. It allows us to transfer knowledge efficiently. And it puts you in that scenario of testing versus analyzing, right? It breaks down those roles in a way that you can look at the code differently, okay? And pair programming, pair coding, and testing breaks down communication barriers, okay? I work quite often with other seniors, with mids, with juniors. We have an hour blocked every day at the organization I'm currently with, and I've done it at others, where we hop in as a group and we might just tackle one problem for that day. Some of the guys might drop off, some stay on. I guarantee you there's almost always 2 in there. So somebody's learning something from the other, or somebody's looking at it going, hey, you're writing this code, but that doesn't make sense because what's over here, and I hadn't even looked at that because I was focused on what I'm writing, okay? So best practices, okay? So this QR is my slide deck, PDF form, okay? So all those screenshots, you get better screenshots now. If you're smart enough and you look at that URL that has the actual URL that my slide deck runs on, so you have access to all the presentations I have, okay? Any questions? We have, 4 minutes? Yes,
Question.
we have a question.
Yeah, it's about you have shown us all this spectrum of
Mhm.
tools, practices, and
Yes.
that kind of thing that we should do. How don't feel overwhelming? I am QA tester. I do automation, but
Mhm.
right now there is a lot of tools and be here, be there. How don't feel overwhelming about that? How should I continue on my path growing as QA?
Ooh. The mentality between QA and developers is different. That's the first thing you need to realize. How many are QA? Oh, good number. All right. I'm assuming the rest are devs at some level. How many are management? Let's ask that question. Okay, a couple. So a couple non-devs in the room. Developers build things. We create things. We like to see things come to life. Testers, QA, what I've found now is it's not an every time thing. They like to figure out how things work by breaking it, by ripping it apart, right? That's a different mentality. And realizing that, I think, is helpful as you look at, like, how do I continue? How do I work with those folks? That different mentality puts a stress in place, right? I mean, it's almost an immediate stress. It's really hard not to. You get a new dev on the team and you QA something they're done, and you can almost guarantee they're going to get stressed out about it, right? It's hard not to as a developer. You wrote this, you created this is your code. It's hard to get away from that. And I switch companies quite frequently, so I get that a lot. And that's where sometimes the pairing comes in. That communication is a critical piece as you do that. So what I try to get my QA folks to do is, rather than just marking it on the card or sending me a note, give me a call. I mean, we're virtual these days, right? Give me a call. Let's sit down and see what the problem is and talk through what to do about it. Do we mark it on the card? Do we create a new card? Do we, get that relationship there, okay? In terms of QA within this, the role in there is probably one of the more straightforward ones that we have in most cases. But you make the team more resilient by passing on some of your skill set and your tooling that can be used to those devs. Hey, you know, here's the script that I use to test your A/B tests, right? I have code that actually creates A/B tests. So they can go to one link and it redirects to other pages. And our tester has this script that she shared with me. So before I release to production, I can run that in my local environment and make sure things are working, right? Which is really cool for me. And you know, in those few times that she might not be there, I can walk somebody else through so that I'm not the one testing my own code, right? In terms of how that role is in there, you know, most developers, and actually what I found, especially with the mids and juniors, is most don't know what a smoke test is, what the purpose for it is, how the manual testing fits in after that, what UAT should be doing. You know, it's amazing how many UAT don't know. Does that help?
Yeah.
Okay. Other QAs, did I miss anything in there? Close? How does QA progress within this kind of a scenario, I guess, within the talk? How does that fit into like career progression? Did I get close enough?
Yeah, I think so.
Okay. There was a question over here. Yes.
Do you have any advice or suggestions for when you might come into like a legacy code base where the testing isn't there? So making a
Pray.
change is like,
Pray. No. This is the last question I got time for. The question was, if you come into a legacy code base, there are no tests, what do you do? Okay. You need tests. Okay. The worst case scenario I've seen with that is a company that has 97% of the money going through the organizations through one class. That one class is one function within the class, and it's 6,000 lines long.
I'm sorry.
And they're going, how do we test this? There's one team dedicated to managing that one file. Okay. And this is a company that does, you know, billions in a year. All right. So what I told them is anytime you modify code, let's pull it out. You know, those 2 or 3 lines that you change, pull it out into another class, test those. Over time, and they're about 80% there after 2 years, you'll have it tested. Test what you change would be my suggestion there. Build it slowly. Make sense? Always leave your code better than when you started. Okay? We are 1 minute over, guys. Thank you.
Very, very good talk. Hope you didn't
Thank
mind
you.
hopping in with the whole
No.
thing. You got the error missing there. I thought it was just fun.
Please do. That was awesome. I loved it. I
wanted
could play to it. I'm okay with that. I found one in my nose. So yeah, lots of spelling mistakes.
I also,
Thank you. Let's step out so the next person can get in.
yeah, they'll get started up.
Yeah. I just need to get away from that desk.
One that's want to connect on LinkedIn.
Oh, absolutely, yes. But let me get this bagged up. What you got?
Can I ask you the microphone?
Oh, yeah, you can have a microphone. Don't we taking that back to Ohio?
Columbus.
That's because that's where it's
Thank
headed in about 10 minutes.
Do you have the link?
Yep.
Okay. Let me see if it's the correct one.
Yeah, I mean, it's like the worry of like getting up, getting all set up, and then after that, being like, great.
Come on.
Oh, you're doing
What's happening? Oh no. Okay, let me just log in this way.
half of it. Other half is actually just talks.
I didn't know they actually have DevOps roles. I was trying to
So it's called something different.
Of course it is. Every company has a different name for their stuff.
Yeah, like it's under
Just pull out your phone. Or your like your camera. Yeah. I just
Okay. Hallelujah. We're in. So let me pull Danny's email. That one.
Yeah, sure.
When you say vendor, do you mean like enterprise, like they bought a license?
No, well,
Or is it a third party company doing it entirely?
you do the dark
We just need that you turn off your microphone and your camera.
I'm sorry, like, you mean like you tell them, hey, we want to do a deployment, and then they, I'm sorry, I'm about to have a heart attack listening to you.
like yes, but it's pretty good. I mean, like, it's definitely has its problems.
Now I need that you set up your microphone. I'm going to let you know when you have 10 minutes left and 5 minutes left, okay?
Perfect, thank
Do
you.
you have any questions?
And I know that here's the thing. I know it's that. I mean, they write their tests. Like they write their tests. They don't always like, but in reality, when you're getting 100,000.
You need to share your screen.
Yep, I was just making sure everything else was minimized.
You are in the right one. Thank you.
And also, like, we configure what we want to be based on our hardware. Because we have they sell us the hardware. There's another team that built it out. There's hardware across the United States. Different data centers.
So that's Verizon.
Yeah.
I mean, like here you talk about that, like it's your code, like communications, not that's how you can test.
Yeah, so like I'm running into the problem of
Yeah, but unfortunately, division of responsibility.
that's what I think, yeah.
Right? I know that gives you a feeling like check this out. We just looked at
That's exactly what it was, because like all traces.
It's so cool.
However, like we. Trying to figure out how to test in that.
I can hide that. Ready to go? Okay. You got it. All right, welcome everyone. Thanks for hanging out on a Friday afternoon. He's like, nope, not me. He's like, see you later. Awesome. Well, my name's Andrew Madsen. I'm an evangelist for Dremio. We'll talk a little bit about that. But today, we're going to just take a quick look at table formats, which have come up a ton in the news. If you're following reInvent, you'd see that Amazon, AWS just did a big announcement around Apache Iceberg. We'll talk a little bit about what that means, why that's important. So please, if you want to continue the conversation, let's connect on LinkedIn. Just a little bit about me. I've worked VP of data at a bunch of different places. I'm also a professor in a bunch of different master's programs. But most importantly, I just got my silver play button on YouTube. So now my wife has to introduce me as an influencer. We'll see how long that lasts. Just a little bit about Dremio. Dremio is a data lakehouse management. We support open source tools, so you can access your data wherever it is, on-prem, multi-cloud, hybrid, doesn't matter. Awesome. If you want a free O'Reilly book, which I recommend because it's like $75 on Amazon, I recommend get the free copy. We wrote the book on Apache Iceberg, one of the table formats that we'll look at today. So please feel free to get a free copy of that. Awesome. So what is a data lakehouse? You may have heard this term coming up more and more. It's been in the news a little bit. You see data lakehouse table formats, data lakehouse catalogs, all kinds of things. We'll talk a little bit about that today and why it actually matters. So a brief history of data storage helps understand like what's a lakehouse and why is it important. And that's a little bit like Stephen Hawking's book, A Brief History of Time. This is a brief history of data storage. So we'll just take a quick look at it because as you see the evolution of data storage, it helps make sense for where we are and where we're going. So in the 1960s, we really kicked off databases, right? Databases were awesome. First database, super structured, well governed, because it was mostly on premises, so it was really easy to just be like, okay. And nobody could really work with ones and zeros anyway. Super transactional because it was really just powering applications. And in traditional databases, storage and computer linked. And for what we were doing, this was awesome. So databases really kicked off in the 60s and did really well. And then things continued to grow. So in the 80s, we had SQL, well, kind of 79, but really it was the 80s where ANSI SQL came out. And now all of a sudden, not only can we pump data into our applications, but we can read data for analytics. It's like, oh, okay, we've got all this data. Now let's use it somehow. So now we've got all these analysts who are trying to pull data out of our database, but analytic queries were breaking the transactional queries. Now we're breaking our application, and so they're telling the analysts, like, okay, maybe just do it at night, and now the analytics are delayed, so they figured, okay, maybe we need a different kind of database. Let's create an OLAP database, an online analytical processing versus an OLTP, transactional processing. We're just going to move data from the transactional database through extract, transfer, load process. We're going to drop it in a different kind of database. You analysts can have that. You play with it. So now we've split transaction and analytics. And that freed up the analysts to do a little more experimentation, to play with it, because they knew that if they broke something in OLAP, it wasn't going to break the transactional database, which was feeding all of the systems. So it's good because now we've got faster analytical queries. We were able to change how the OLAP databases were structured so that it can pull those analytics much faster. We still have a lot of the same benefits that we got from traditional databases. Storage and compute are still linked, meaning that if you want to increase your compute, you have to increase your storage. And if you want to increase your storage, you still have to increase your compute. Everything at this point is still on-prem. And this worked pretty well for what we were doing all the way through the 90s. Oh, I've got it backwards. That's okay. So also in the 80s, we had relational databases come out, right? So relational databases where now we have schemas. We understand how tables work together. We've got primary keys, foreign keys. We're doing normalization. And this works pretty well. But now we've got the internet. So internet really kicks off 1993, 1994. Tons of new data that we need to use and process. Databases cannot keep up with it. Our transactional databases are still doing okay because they're primarily just powering applications. But our OLAP analytics database is not keeping up at all. And so Bill Inman in 1992 says, hey, I've got this new engineering pattern called a data warehouse, which is still around today, still a valid engineering pattern, where essentially instead of having a bunch of different databases for specific use cases, the idea was, let's get a central repository for our analytics. Let's put everything in there, and all the analysts can pull from this one repository. And so it did a few things. They were able to switch from row format to columnar format, which is much faster because you're limiting the amount of data that you either have to read or write, which is fantastic. For the most part, it was still on-prem at this point. Super fast analytical queries in a warehouse, especially compared to what they were doing. But what happened? And we see it today. These analysts were creating specific use cases. Maybe they were making little data marts off of this. And then this group set up their own data warehouse. And then this group set up their own data warehouse. And then this business unit set up their own data warehouse. And then we acquired this business unit, and they had their own stack. Now we've got data all over the place. So instead of having Bill Inman's vision of a central repository, now we've got a bunch of distributed repositories, data silos, right? We experience that today, where business units don't talk to each other. If you want to roll up enterprise level analytics, it's almost impossible. So it's a challenge. Also, it's still only dealing with structured data, which with the internet and the amount of data that we're receiving, there's a huge opportunity for unstructured data, which is where the data lake really comes in. So the data lake really kind of kicked off on-prem with Hadoop and Hive, but shortly afterwards, in like 2006, AWS launched S3, and everybody else followed shortly afterwards. Now we've got data lakes where we can put unstructured data, semi-structured data, whatever data, we can drop it in here. And not only that, but we can do it in the cloud. So now instead of having to build a physical server, now we can just do it now we can use Jeff Bezos' server, right? So we can just put it up in the cloud. Awesome. Now storage is suddenly cheaper. And now we're separating compute from storage. Awesome. It gives us a lot of flexibility for elastic scaling. Fantastic. But there's a lot of issues with data lakes. There's a lot of challenges with traditional data lakes. So one, analysts can't really use it because of the type of data that's in there. Try telling an analyst to pull data and be like, oh, well, just figure out the key value pairs of that file. It's not happening, right? They're going to still go to their data warehouse. You might have S3. They're still going to Redshift or Snowflake to pull all their data. So it only increased the amount of data that we were storing for the most part. It made it quote unquote accessible, but not usable, if that makes sense. And so data lakes were awesome for being able to increase the amount of storage that we had, but it didn't really help usability. It did in certain use cases. Machine learning was able to figure out a lot more patterns based on data lake data, but analytics still really depended on that structured data. We've got multiple ETL processes, so data lakes didn't really solve a challenge for us. It didn't give us many solutions other than being able to store unstructured data, which is great. But now we've got a bunch of ETL pipelines. And one of the challenges with pipelines is they break, right? Everybody's been on pager duty and like, oh, crap, my Spark job failed. Let me figure it out. And so many organizations have thousands of Spark jobs. They fail. And now we've got duplicate data in multiple places. And so if you're pulling from the lake or you're pulling from the warehouse, it could be different. That's an issue. So many organizations today, I go out and do a lot of consulting, they have a data swamp, right? They're like, oh, we have a data lake. Like, okay, how are you using it? They're not really. They're like, well, we have Snowflake, and that's what we really use. When I was at a university leading their analytics team, I just joined, and I was trying to catalog all their data and figure out the use cases. And I saw that they were tracking the key card swipes for every student. They had 50,000 students on campus, and every door you had to go in and out had a key card swipe, right? And they're tracking all of these swipes and dumping it in the data lake. I'm like, why are we tracking this? They're like, it's useful. Like, awesome. What are we using it for? They're like, nothing. So I'm like, okay, great. So we had a data swamp because it was just going in there. Nobody used it. That's where we were at. This is where a lot of organizations are. Duplicate data. We've got a data warehouse, but we've got a ton of data we're not really using. Enter the data lakehouse, kind of mid-2010s. Really 2016 is where this kicks off. What's a data lakehouse? So if you think about all those benefits of that data warehouse that we looked at, I know I'm flying through this. This is normally like an hour-and-a-half conversation and workshop, and we're going to crank this sucker in 25 minutes. All the benefits of a warehouse were analysts can use it. We've got ACID transactions so that it's either all or nothing, right? If you do a transaction, not part of it's going through. It either all goes through or it doesn't go through. It's durable. Incredibly usable. You can find the data. What if you could do that all on the data lake where all your data is? That's what a data lakehouse strives to do. So it tries to give you all the benefits of a data warehouse on top of your data lake. So you don't have to move it. You can just do it on S3 or on-prem or Azure, wherever you are, or multi-cloud. And you can do it with open source technology. So incredibly analytics friendly, optimizes your cloud costs because now we're not duplicating data. It helps your ingress and egress fees, right? Which hopefully, fingers crossed, go away. It's kind of like cell phone minutes, right? When they used to ping you for nights and weekends. That's how I think about egress fees. They're silly. But if you have to constantly move it in and out, you're getting dinged all the time. But if you just drop it in the lake and then you can use it from the lake, incredibly helpful for most organizations. So this is where we end up with the lakehouse. So how do we get a lake house? Well, this is the super basic structure of a lake house, but it gives you the general idea. So all your workflows hit a lakehouse catalog, and it's a metadata catalog. So not your enterprise catalog like Calibra, Lation. I wish they chose a different name than catalog, because I'm like, dang it, come on. And nobody gets it. They're like, oh, so I can use this and not a Lation? I'm like, no, you need both. So metadata catalog. The catalog will use one of these table formats. All these three are open source: Apache Hudi, Apache Iceberg, and Delta Lake. These table formats through manifest, they do it different ways, but organize all your files in the data lakes into tables, right? So all these files sitting in there, this JSON file, this Parquet file, in the data lake may look separate, but the table format will know that those actually equal a table. And so you're able to run your queries through insanely fast because of the way that it does optimization and pruning. So let's take a quick look at each one of those. So Apache Hudi was the first to kick off. They all kind of launched about the same time, but this was 2016 where Hudi really came, and it came out of Uber. So Uber was struggling with the amount of transactional data that you have. If you think about how Uber works at like a basic level, what do they prioritize? The most recent transactions, right? They're not really thinking about, oh, I need to go back and snapshot this data. They're really get it in as fast as possible, use it as fast as possible, vacuum it, right? Get it out of here. We don't care. New data in. That's what Hudi really thrives at, is ingestion and transactional processing. So lots of different use cases similar to Uber. Lyft doesn't use them. Maybe it was I don't know, Lyft uses Iceberg. Who knows? Maybe they're like, we don't want to be like Uber. But insanely fast with transactional efficiency. So there's a big use case for Hudi. It's not probably the most widely used. I think I can say that pretty definitively, that most organizations' use cases don't align with this. But for those that do, awesome for that transactional processing. So if you think about Uber, that's kind of like the star use case of what you'd use Apache Hudi for. And if you're familiar with open source, there's multiple versions of open source. The two big ones are Apache and Linux. So Apache is community run, where a bunch of different companies and contributors are on the PMC. It's really community led, versus Linux Foundation, which is Delta Lake, where it's generally run by a company. So like Databricks runs Delta Lake. Apache Iceberg rolled out of Netflix in 2017. So similar challenges, right? The vast amount of data that they had, they were struggling to make recommendations efficiently, to run their machine learning models on top of it, to do it insanely fast, but also cost effectively. If you want to limit the amount of data that you're ingesting, you need to do it columnar, which is, remember the golden rule, use Parquet because your mother told you to, because you love your stakeholders and also money. So Netflix really optimized Parquet, but it was really only given that columnar benefit. They were trying to do compression. It was working a little bit, but not enough. So they invented Apache Iceberg and open sourced it. Databricks just bought the company that from the founders of Iceberg for $2 billion. So they're doing well. And they only had $1 million in ARR. So that's quite the valuation. Good job, Ryan Blue. Apache Iceberg's a different use case. It really emphasizes more of batch processing and taking those historical snapshots of being able to look at exactly what your data was at a specific time, which is insanely helpful for machine learning and AI when you need to go back and back test your models and see exactly what your data was on a day and time. That's where Iceberg comes in. So it does partitioning, schema evolution, hidden partitioning, super helpful. So ACID transactions, very helpful. But streaming, it works with Kafka, but I would say that's beta. I wouldn't say that working with Kafka is a strength of it. So Delta Lake rolled out shortly after Hudi. It came in 2017, but Delta Lake and Iceberg were developed about the same time. And now the inventor of Apache Iceberg and Delta Lake both work together at Databricks. So Databricks, if you're not familiar, is machine learning. That's really where they came from. That's their bread and butter. They do a bunch of different stuff, but machine learning and AI is really their mantra. Their founder is one of the folks who invented Apache Spark, so they crush at streaming and Spark management. Really good at streaming in Delta Lake. It's very similar to Apache Iceberg. There's nitty-gritty stuff. If somebody from Databricks was here, they'd be like, no, it's not. Yeah, it is. But you have to kind of be locked into Databricks. Delta Lake doesn't really work with anything outside the Databricks ecosystem, but that is changing. So more of a streaming use case versus Iceberg, which is a batch use case. But again, all of them work similarly. They're all sitting on just on top of a data lake or multiple data lakes, S3, Azure, GCP, on-prem. Incredibly helpful. But what's coming? So like these have been around for 5-6 years now, but now suddenly they are in the news. Up until about 2 years ago, it was tough to convince large enterprises to move towards an open table format because they're like, well, should I go Delta Lake? Should I go Apache Iceberg? We don't know. It's kind of like Blu-ray versus Betamax. It's like, I don't want to pick one and then have it be obsolete in a year. That's really where it was going. But after Databricks acquired the founders of Apache Iceberg, that was a huge signal to the industry that Iceberg is the industry standard. And that's really the signal that Databricks is giving everyone because they announced that Unity catalog will now start working with Iceberg. And the Snowflake catalog, which they're both open source, but the Snowflake catalog for Iceberg Polaris will also work with Delta Lake and Unity. So that's where everything's going. Organizations are tired of really trying to stress about the table format. They're really just trying to find parity and who has the most accessibility without vendor lock-in. Because the beauty of having a lakehouse is that you can get your own query engine. You can use whatever storage you want. You can pick and choose your metadata catalog. You're not locked into a vendor if you do it correctly, and you can do it completely open source if you want. So Iceberg launched the REST specification where really any engine can talk to any catalog as long as they read that REST specification. Unity's following close behind. So we think that this is really where things are going, that everything ideally should be able to talk to everything. Ryan Blue, the creator of Apache Iceberg, said that. He's like, we're tired of this. We want everybody to just kind of focus on business problems rather than stressing about which one of these 3 table formats should I choose. Iceberg really is the industry standard. We just saw the announcement from reInvent that S3 is going to give Iceberg a first-class experience in Iceberg tables. So that's big news. But again, Unity catalog is going to try to read Iceberg. So then you should ideally in a couple of years be able to work through that. So that's really super fast. Where did we come from? Where are we going with table formats and why it's so important? Because now think about like how messy a typical architecture is with all the data silos, with all the wasted costs, with all the duplication. If you can consolidate all of that and use an open table format and an open catalog and democratize data while still providing ACID transactions, governance, compliance, I mean, that's the sweet spot for everybody. And that's where we're all really trying to go. Awesome. And I got 2 minutes for questions. Awesome. Anybody have any questions? Did I blow your minds or put you to sleep? It's okay if I put you to sleep.
Okay, the whole time I was like, why lakehouse? Like, why did they choose the word lakehouse?
Yeah, well, some people chose ice house, and I'm like, come on. But lake house because it's on the lake, but it has the characteristics of a warehouse. I mean, if you talk to Bill Inman, who invented the warehouse, he would say, well, this is just an engineering pattern, and really a lake house is a warehouse, in his opinion. But it's all of the benefits of a warehouse, but on top of the data lake. So you don't have to do that ETL into a separate storage. So think like if you dropped everything in S3 and then you have to do all these ETL pipelines into Redshift or into Snowflake, sometimes multiple, that's how folks are doing it now. Get rid of all that and just do it straight on top of S3 with all those benefits and governance. Saves you tons of time and money. Awesome. Thanks, everyone.
Sorry, I missed the QR code. Can I connect with you real quick?
Yeah.
Awesome. Thanks so much.
Of course.
Yeah, it's been a while since I been messing around with Delta Lake and all that, but probably gonna start doing it again pretty soon for my job. So
Good.
Yeah, so it'll be good to get back into this.
I know it's coming up more and more.
Yeah, it's coming up more and more. It's definitely something I need to get using.
Come on. I broke it.
Oh, you're good. Worst comes to it, you could just give me
I've got it on a card.
Oh, okay, got it. I was like, whatever works, I got it.
Oh, there we go.
Okay. Perfect. Thank you so much.
Yeah, my pleasure.
Yeah, perfect. Yeah, have a good rest of your day. Thank you.
You too. Thank you. Yeah, sorry.
Thank you so much.
Yeah, my pleasure. Here you go.
I don't know if the next speaker.
She's the next speaker.
Oh, okay.
So don't forget your.
Or it's not charging fast. Yeah, strange too fast. So I left off of the speakers.
Oh, for you know, I stay ready for good news. I'm playing. No, I remember last time I got one and I came back around for another one. She's like, well, I don't know if I have enough for everyone to have one.
Hello.
So you can't have two. I got two.
Hello. My name is Angela. I'm going to help you as monitor today. Thank you. So.
Okay. I love how much y'all got the scrunchies.
I know, they're nice.
You go put your dreams up, your hopes.
I can't get one.
Do you have the link? I think Danny sent you the link for Greg to. Okay, let me. Yeah, do you have it? Maybe in the. Should be in the calendar or.
This one?
That is not the one. Maybe look to the other. That is the one. Yeah, that link. This one? Yeah. Okay. We need that you turn off your camera, your microphone, please. Oh, wait. Turn it off or turn it on? Turn it off. Off? Yeah, off. I don't think no. I think you need to allow the access. Yes, sorry. And now you can turn off. Can you display your name, please? Yes. Yeah, that's it. So what now I need you to set your microphone. Hello? Hello? So what is this? Yeah. You need to present your screen. Oh, okay. It's all okay. Let me get my presentation. I wonder if I take my case off. Does it work? Yeah. Wait, do I not have a mic? Oh, whatever. So, hi everyone. My name is Yoon. This is my talk. Oh my God. Okay. So, all right. Thank you. So, I'm going to be talking about infrastructure as code and how it's a must-know skill now for today's developers. So, who am I? My name is Yoon, as I just said, and I work at NBC Universal as a software engineer. And I'm also known as the Dallas Software Developers Meetup Group, like Cookie Lady. And at the end, I brought some cookies so I can pass them out later. So, bribing you guys. So, before I start my talk, I wanted to ask, who here is trying to get their first job in tech? Okay, so it's like half the room. And then I want to ask, when you start looking at your job listings, have you ever seen the words like AWS, Azure, CI/CD, Terraform, or like containers? And then who here has a job in tech and is working already? Okay, yeah, it's like an even split. And then from y'all, like in your day-to-day work, do you use any IAC tools? Yeah, like a good chunk of y'all. Okay. So as you can see, nowadays IAC is pretty commonly used, even though it's deemed as DevOps, but it kind of expanded upon that because of the cloud adaptation that is widely spread throughout all the companies lately. So I will be telling you why you should probably learn it if you want to be competitive in this job market. So what exactly is IAC? IAC, by the definition from AWS, is the ability to provision and support your computing infrastructure using code instead of manual processes and settings. So what this means, instead of directly creating something on like the console, you are writing something with code
quote unquote, and then you're basically telling something to build this for you on whatever cloud. And then there's two different types of IAC tools. There is declarative and imperative. Declarative is the one that you'll see most often because in declarative, you define what the final state of what you want. You don't tell it how to build it. You don't tell anything like in between. You just want like, I want this, and then it'll do it for you. And some common examples are Terraform, AWS CloudFormations, Pulumi, and then probably all the ones you've probably seen are probably declarative. And then there's imperative. Imperative is basically you have to give it all the steps, and it's very granular to get to that final outcome. So this way, it's a bit more complex, a bit more advanced. And honestly, I've personally never seen it used at a workplace, but Chef is one of the programs that you can use if you want to go this route. But the most common way is definitely declarative. So why does it exactly matter in today's developers? So there is this whole modern work expectation where cloud is everywhere. Like if you look at any job listings, they always list cloud in there, whether it be AWS, Azure, or GCP. So if you want to be working in that setting where you're working with modern technology, because I know that's like the new shiny thing, right? Like you probably went to boot camp or something and you're looking for your first job. You want to work with the latest tech. You want to do the shiny stuff. But if you want to do the shiny stuff, it's probably modernized on the cloud. So that's one thing. And then the next thing is that it bridges the gap between code and development. So when you're working in a work setting, you have multiple environments. You're not just having like prod and that's it. I mean, I guess you could, but I don't recommend it. But the normal settings is usually there's a dev, like a stage, maybe a QA, and then there's also prod. And these environments typically mirror each other. So the easy way to do that is using infrastructure as code, and you just deploy it into multiple environments. But that way, you know, your resources are consistent in every single environment. And by doing that, you have that consistency and you know it's consistent. So you have a better ability to debug and like troubleshoot before it even gets to prod. So less downtime in prod and less issues essentially. And then that kind of goes with my next point where it promotes consistency and automation because of that consistent resources in every single environment. It's pretty easy. You just write like a template and then you throw it out for every single environment. And then also tied to that, like I said, like the word keyword like CI/CD, infrastructure as code and CI/CD pretty much go hand in hand. Your infrastructure as code is a file. It's like a code file. You push it to your repo, and then it technically triggers a pipeline, and that pipeline will include those resources. In that pipeline, you'll build your resources, and you'll also deploy it. So if you want to get into the whole like automated prod releases, you've probably heard that like buzzword all the time. You'll have to use IAC. And then lastly, the developer and the team itself, you'll also get an increase in efficiency because before, it was the DevOps team or the cloud team that were making these infrastructure for you, and you would have to wait. You would like submit a ticket, be like, I need this resource. Who knows when they're actually going to build it for you? It could be like tomorrow. It could be 6 months from now. You never know. So you don't have that dependency of having to rely on another team. You can just do it yourself, and you won't be blocked by that. So what exactly is Terraform? So Terraform, like I said, is a declarative IAC tool. It's written in HashiCorp configuration languages, it's HCL. And I know it's a little spooky that you have to like learn another language, but I promise you it's pretty straightforward. If you can read English, you've probably got most of it already. So as you can see an example, that's literally HCL. Like if you just read it, it's pretty straightforward. It's nothing super complex. And if you just go like online on hashicorp.com, they have really intensive documentation with examples of how to do pretty much every resource available on all the different clouds. One of the things that Terraform is really known for is its multi-cloud support. So that's probably one of the biggest things about it, is that it is cloud agnostic. So any team that uses a multi-cloud structure will benefit greatly from Terraform, because you would only need to use one tool and you can deploy it to every single cloud. And another nice thing about Terraform is that it does state management for you. How Terraform does it exactly is that it creates a specific state file for you, and then you can store that state file, whether in like an S3 bucket, your repo, etc., any type of storage. Also, say like maybe you got like a new junior on your team. They're not fully aware of what IAC is. So instead of configuring and updating the resource via Terraform, they go into the cloud and they just like manually adjust it. Well, the state can actually detect any drifts. So if you know something got changed, or you didn't even know something changed, it'll tell you that something got manually changed and let you know to like fix that. And one of the biggest benefits that you have with Terraform is that you plan before you execute. So one of the biggest things about Terraform is that you can do Terraform plan, and then you can do Terraform apply. So these are CLI commands, basically. In Terraform plan, what it'll do, it'll compare the state of what it is already done and all of the changes that you want. It'll compare that and tell you what exactly is going to change, so you can see what's going to update, how it's going to update, and what the values that are updating are. And then if you see any mistakes, then you didn't apply it yet, so you're good. Like, it's just there as a draft. And then once you're secure that everything is how you want it to be, then you press apply, and it'll go and shoot it off into cloud and do whatever magic there. And now infrastructure lifecycle management is. So Terraform gives you ability to create, update, and delete. One thing that's nice about this is everything can be done as like a whole for each Terraform stack that you create. And because you can do it all as a whole, you won't leave any like straggling resources behind, because you guys probably all have heard the horror story. Like if you do like an EC2 instance and you just forget about it, and then you get charged like thousands of dollars at the end of the month. With Terraform, you don't have to worry about that, because if you press delete, it'll make sure it's deleted. And then lastly, Terraform promotes an immutable infrastructure. So instead of manually having to change everything, all you have to do is configure something and put that update and then push it. So that it wants you to get into the habit of that instead of actually manually doing anything on the console. Then we have, what is AWS CloudFormation? So this is another popular tool that's used, but as you can tell by the name, it's very native to just AWS environments. So if your company or your project is pretty much only using AWS, this is a good choice, because I would say it's pretty beginner friendly, because it's written in JSON or YAML. You don't have to learn a new language. And I'm pretty sure all of you guys know what JSON or YAML is. And then because it's AWS native integration, anything that changes with AWS, whether it be a new update, a new feature, etc., CloudFormations will get the first support. So you don't have to worry about does Terraform or Pulumi, etc., is this actually getting supported yet? CloudFormations will do it right away. And then the way with state management, like I said, in Terraform, you have your own file that you store. CloudFormations doesn't really do that. It kind of does everything for you. So AWS is very famous for, they'll do it for you and like take less work, like make you do less work, and they'll do it all behind the scenes for you. So what they do is they have this like CloudFormation smart thinking. I don't really know what the exact word is, but it will basically keep it in mind in the back. And then when you have your resources listed, you don't have to write like, oh, well, this has to build first, and then you can do this. CloudFormation will automatically figure it out for you and then do it in the correct order. And that's a part of like the infrastructure lifecycle management. Like you don't have to worry about like, oh, well, how do I make sure X comes first? And then this one, like if I wanted to make a database, I probably need the proper permissions first. It'll create all of those permissions and then the database. And then you also have the ability to see everything in a nice, neat stack on the console. And you have the ability to just create, update, and delete everything all at once, kind of like Terraform. You also can see change sets and resource imports. And these are all like, if anything got manually created, you can automatically put it into your CloudFormations template and just make it match. And then automatic resource dependencies handling, with the same thing I said earlier. And then cost management. So before you even apply your settings of what you want to be deployed in AWS, you can actually do a cost estimate on AWS to see what these potential things will cost. So these are some recommendations of what you should probably learn on top of IAC, because IAC is built upon these foundations. So like cloud provider basics, you should probably know what resource you want to do, right? But you don't have to learn everything. Because, for example, like if you're front end, you're not going to use everything out there. Like AWS, Azure, GCP, so many resources. You don't have to know every single one of them, but there are probably common ones like an S3 bucket. You're probably using that for storage. So learn what's common to what your job or your stack is. And then also, you should probably learn about identity and access management, because you need to understand permissions and how they go hand in hand with resources. And then networking basics. Cloud is literally built on networking foundations. So if you're not understanding like what is IP address, what are subnets, what are load balancers, you're going to have a tough time writing proper IEC. So I do recommend you should probably, you don't have to learn everything extensively, just learn the foundations. And then because if you want to do automation, you should learn about CI/CD pipelines. A free one that you can do is like GitHub Actions. And then lastly, Linux fundamentals. Linux is really dry, I'm not gonna lie. But it's pretty important if you're going to use the cloud, because there will be times that you're going to deploy something and you want to troubleshoot it. And how are you going to do that? You have to SSH into their little instance. And that's all in Linux. So you should probably learn the fundamentals of that. And I know I learned it too. It was not fun. But there's a game you can play that I actually do recommend. It's called The Bandit Game, and it's on overthewire.org. And it's a game you can do to learn all of these Linux commands and how to like go around in the terminal. And that's one way to do it. And I do recommend that instead of just like reading a book. And yeah, that was my presentation. Do you guys have any questions?
I have a question.
Yes.
So you mentioned about the cloud formation, it creates all the rules.
Mm-hmm.
Does it create all the IAM rules and roles?
It won't create it for you, but if you define it within like your template, it'll do like an order of like, I'm going to make this role first because this thing is dependent on that role.
Like in the UI?
No, just like CloudFormations itself will like automatically do it for you. Yes.
Let's say I'm already in the cloud and I want to use Terraform to then keep it as code. Is there an easy way to take what I already have set up and networked and wired together and make it in Terraform code?
I believe Terraform has a thing similar to CloudFormations where you can take like manual things and like import them into Terraform. So, but I could be wrong, but I think there is. Yes.
If you're all AWS, are there any advantages to using Terraform over CloudFormation?
I think Terraform is pretty much the industry standard. So I wouldn't say it's like an advantage or like a disadvantage. They both have their quirks and they both have their annoyances. But yes.
Now, if I may add, don't use CloudFormation.
I would say Terraform is pretty much the standard, because Terraform is a skill that every company will use. Every company will have a Terraform somewhere used, maybe not on the current team that maybe you're looking at, but another team will be using it. So I think as an industry as a whole, Terraform is probably the most widely used, but they're all both basically the same. Like the core concepts are the same. So if you learn one, you'll pick up the other really quickly.
How many resources can one person manage? For example, how many resources are you managing right now?
I think my team, our cloud formations, we're using cloud formations and we're using AWS SAM specifically. I believe we're managing about 400 resources in one file. It's a very large file. I think it's like 6,000 lines of code, but it's a lot.
Follow-up question.
Yes.
6,000 of lines. How do you debug it?
So don't follow what my team does. I don't recommend actually doing one file. But you can do like a nested structure of like, I want these specific modules in like this file and this one, this is like the parent. So you can have that child and parent relationship in these IAC tools. You can do it in Terraform, you can do it in cloud formations. Every IAC tool is like that, but yeah, don't follow my team's example. Not the prime one here. Oh, yeah. Are you sure? All right. Cookies. See, I'm here to bribe you guys, so.
I have one more question.
What?
Did you enjoy this?
Oh my God, like, why did you guys do this? Oh, yeah, I'll just like, I'll go through real quick. No problem. Okay, hold on, stop. How do I stop this? Leave studio?
It's okay. Okay.
I know that whenever I do my model my goals, talk you better.
Okay, Nick, you are right.
Does the clicker work? It doesn't. Okay. I can hear myself.
He is going to start now.
Thank you.
Okay.
Hi.
Start, please.
Hi, everyone. Sorry. Before I start, just wanted to ask if we have support engineers, cloud engineers, DevOps engineers here. No. Yeah, I guess they're all gone. So today we are talking about building smart support systems using Amazon Lex specifically. So as we have the cloud environment becoming very complicated and very complex now, you need to build systems, cloud systems that can counteract and help you in your daily operations using the cloud. And specifically with this one, we are looking at using Amazon Lex, which is more like a machine learning and a fully managed AI Amazon service, right? So let's look at what Amazon Lex is. So it's a fully managed AI service for building conversation interfaces using voice and text. So you just don't go in, run, build, bring up a resource, but then you have like an interactive front end where users can go in and then have a chat. So more like a chatbot, right? But this is normally built and then trained with data you would want it to respond with. So you would want to provide the users and then the end users basically with specific informations when they ask it, right? So you would have it built that way. And it takes in voice and text. It's not just text only. It uses like natural language understanding. So this basically makes it understand the text that is being inputted. So it doesn't really limit it to keywords. So some of these systems actually just look for specific keywords in there, and then that is what it searches its source data or its knowledge base from, right? But then this uses the NLU and machine learning. And it's only you only pay for what you use, right? So with Lex, you pay 0.004 for speech request. So it does the whole request response, and that is how it gets calculated for like pricing. So it's 0.004 for speech, and then 0.00075 for text. I mean, text is much common, so that's like much cheaper. Using how do you call it? Speech means you are utilizing a different resource also built into it. That is more like the automatic speech recognition, right? So you have it, these are the features. You have it using the natural language understanding, which makes it make meaning out of what you put in, then the automatic speech recognition. So you just don't talk into it for it to just pick keywords. It understands what you're saying and then responds accordingly. Then we look at it having multi-channel deployment. The multi-channel deployment doesn't necessarily just limit it to its interface or its experience in AWS, but then you can integrate it with other third-party services, so probably Slack, Jira, something. So if you are looking at having like teams where maybe issues come up, it gets raised in there, it can automatically raise like a Jira ticket, maybe HubSpot ticket, something. You can because you have like, you can have like a full backend processing, right? Where you can probably also use other AWS services, like maybe having like a full Lambda function running where you can have it in there. It can call direct APIs, or once you can do anything programmatically, right? You can use it in there. You can have like a function running fully. So this also uses, takes advantage of those deployments, and it's serverless. So it scales as and when, depending on the requests coming through. You don't have to manage any infrastructure. You don't have to go in to probably scale. You don't have to manage any of those things. Like I mentioned earlier, it's a fully managed AWS service, right? So this scales automatically, handles your load, like takes care of everything fully. And if I mean, if it can be integrated with third-party services, definitely can be integrated with AWS services, right? So here you can have it integrated like almost all AWS services, Lambdas, CloudFormation, like you mentioned, right? So you can have it create resources. Probably you just go in, I want to create like EC2, depending on how you've built it, you can have it built with specific responses. So you probably want to create an EC2. It would ask you which type of EC2, what size do you want, everything. It will just call, maybe if you have like a predetermined CloudFormation template running, it will just run it, create your resources, and then that's it. So I think this service in itself looks at streamlining operations generally. Because once you have this, you basically reduce time in doing some of these manual tasks, right? You don't have to manually go in to do a lot of things. You can integrate this with CloudWatch, where you would have like a metrics coming directly to the bot. You can ask it what's your instance is running on. It can tell you it's CPU, it's memory, it's everything. Once you've built it, and then you have this integrated services in there. Now let's look at it specifically for cloud support. Why would you be looking at this? Because I mean, Amazon Lex is a machine learning AWS service, right? So why would you be looking at it for cloud support? Basically, like what I mentioned, it helps with like services, operations. It will streamline everything, makes you reduce manual tasks. It will basically, and cost-wise, it's cheaper as compared to having like full teams running on call and everything. If you would have like a service like this running, you can have anyone go in anytime, any day to put in what they want to do, and it can be done. It takes out like the human interface as at that point. But I'm not saying you should take out humans completely. I mean, that's not what I'm saying. So it just helps. It runs 24/7. You have that availability all throughout. Then cost efficiency. So like I mentioned, if you are doing it this way, you have it access anytime and everything. That eliminates manual tasks and everything, because you get to automate all of these things. You don't have to have people go in to do these things. Everything gets optimized because of its machine learning feature. Once you go in to interact with it, it tells you like what service, and depending on how you've built it. So everything, it doesn't just come automatically, right? You build it, you build a bot, right? So depending on how you build the bot, it interacts accordingly. So if you've built a bot to recommend services per what you want it to do, it would interact accordingly, recommend a type of instance you want to run, depending on maybe the workload you are looking at or how long you are looking at running it. It would actually recommend that to you, which will help you also like save cost. I mean, not as like a team organizationally, because I mean, once you're saving cost with your services you are running, it benefits the organization. Then faster resolution times, because it takes away the human interaction. You can just go in, okay, I want this done, I want this done, I want this done. It gets it done automatically. It calls APIs, direct APIs. It has services integrated. So this doesn't need someone now coming in or anything. Once you probably have a form of authentication in there, right? If you have authentication in there and it authenticates and it knows this is a valid user, because this user is the one raising this request, I can create these resources. It will go ahead to create it. you probably don't need any form of approval or anything once you have that form of authentication in there. So then as at that point, you'd have all your resources or whatever you want to do in time, which would then definitely reduce resolution times. Then scalability. So with what I mentioned, it's running the serverless architecture, it scales by itself. With any type of workload, any type of request coming in, anything, it can be as huge as whatever it is, it handles it. And you only get charged for the requests coming in. So it's directly correlated, right? The more requests you have coming in means it would need to scale to accommodate it, right? So if you're paying for the request, if it's the request response type for payment, if you're paying for request, meaning if it scales accordingly, you'll be paying more for your request. You get it? Because it wouldn't scale higher if there's no need for it. Once it's scaling means there's a need for it to scale, meaning you have more requests coming in. So there's that feature which also helps cloud teams. So you have like maybe your support teams where they probably don't have to even think of managing infrastructure or anything. They can just leave it to run, it scales by itself and everything is fine. Then there's the enhanced user experience. Building the bots gives you that interface. So you go in there, you interact with it. It's just like going in to have like the chatbot discussion, just more like you go into ChatGPT, this, you ask it answers you and everything. So that also gives like that enhanced user experience. Now there are some real world cloud support examples I put in there. So we have real-time resource monitoring. So this can be achieved if you probably have, let's say, look at, I don't know if you guys know CloudWatch, but CloudWatch is like also an AWS service, right? You can integrate this into this and then get your metrics from whichever resource or whatever it says you are running. You get everything in there and directly ask the your bot what it is, and it gives you like direct responses. You don't have to go in to log in, probably check dashboards or anything. Just the interaction with the bot gives you all the metrics you want. So you can get all that real time, right? So you get to monitor all your resources and everything real time. Then there's the resource deployment. So you can also use this to deploy resources, like creating EC2 instances, provisioning an RDS database, something, anything. Once you want to get it deployed, you can have it done if you have built your bot that way, right? So like I mentioned, it's not automatic that you just create a bot and it automatically handles these things. So you're probably creating a bot where you probably need it for resource creation, let's say EC2, right? And you have a backend processing cloud formation template, which you've specified the resources and everything it needs to create. As part of creating a resource, it specifies like the security groups, the VPC, puts in the CIDR blocks and everything, right? It creates everything directly for you. So once you go into the bot, you interact with it, you probably ask it, you are creating this resource. If you have recommendation services also applied to it, this can also recommend a type of resource you should provision depending on the need for the resource you want to provision, right? So it helps with like resource deployment. Then let's look up 10 minutes, okay. Permission and access queries. With cloud support teams, you probably have these type of requests coming in frequently. Someone needs access to this. Someone needs to be added to this group. Someone needs to access this bucket. Someone needs to do this, right? Once these things come in, if you have one built this way, you probably don't even have to go into that to do these things manually anymore. So again, depending on how you've built the bots, probably the only thing you need to pass in will be the unique username, which then creates it. Then you probably add in a group it should be added to. Maybe you might have a developers group or maybe engineering leads group or something, right? And you have permissions applied accordingly. You wouldn't want permissions just flying out there, right? We all understand the least privileges when it comes to permissions. Now, looking at it that way, if you have groups that have like permissions attached, means you are looking at having users put into specific groups. You get it? Now, if a request comes for a user to be given a specific permission, you can just pass in user name, because then it's going to be a new user. So you probably pass in the unique username and the group the user should be added to, and then that also gets done. So I think all this gets achieved when you understand what you as an individual or the team wants to achieve, right? So if you understand what you're looking at achieving as a team, you understand maybe the tags that come in frequently, you probably want to eliminate them and have like them automated. The tags that come in like from time to time, you don't really have to always manually go in and do all these things. You can automate all these processes in, and then once you have that interaction with it, it just passes in directly and then gets it done for you. Then instance start or stop automation. Definitely, if we can deploy instances, we can start and stop it, right? So this is probably just like a minimum or like a very minimal real world instance, because you can probably do much more with it. But then if you can create the resources, you can actually create it. You can probably delete it. You can start and stop it, definitely. You can have this automated. You can put it in certain processes where you check, and if CPU reaches a particular metric or something, you just want to reboot your instance or something, depending on how you people do whatever it is in your organization or what the need for it, right? So it's a need to basis. Then the cost of optimization metrics. So with this, I know once you have a service like the anomaly, the cost anomaly in there, you can also apply that to it, which will also recommend how to go about the provisioning of your resources. So this will also help you optimize your cost when it comes to looking at using like other resources and other services within like AWS. Now, we are just looking at some basic principles when building the bots, right? And with this, start small, then expand. That more is that's targeted towards the way you probably run with building products. So like the way you have MVPs, right? If you're building a product, you don't just jump in with all like the crazy requirements and all the complex things. You are probably looking at it, maybe you have your first MVP, you get that done, that's working, you probably move to next, maybe newer features and everything. Because sometimes it can also get complex and complicated depending on what you want to achieve, right? So you start small, then you expand gradually. So if you start probably with the first, you're able to achieve what you needed to within that first, let's say MVP, then you probably expand it gradually. And then leveraging analytics for continuous improvement. So like I mentioned, having something like CloudWatch in there for you to like get the metrics in so that you can actually know how it's performing, for you to see how to optimize it, certain changes you need to do and everything. So this is more like putting it in like a testing phase where you go accordingly. Once you get like the analytics for it, how it's performing and everything, you can tweak it, make changes depending on what you want to achieve, right? Then prioritize security. I mean, security is everyone's priority. If it's not, it should be a priority. So prioritizing security also comes in where you probably, like I mentioned, having like maybe an authentication bit of it. You can't just have anyone just use the bots and do whatever they want to, because within the, let's say, CloudFormation or whatever it is you'll be using in the backend to process the request and everything that comes in, maybe you might have allowed permissions once the person meets it. So if you go in and you don't prioritize security and you have anyone just coming in to just do whatever, it means anyone can basically just do whatever. So maybe there should be some form of baseline security, probably authentication, just for you to authenticate this is a user that has the permission to do this, right? And then finally, you keep the humans in the loop, because there are certain things that will probably go beyond that needs to be escalated, right? Where you need actual humans coming in now to. So this also doesn't eliminate the fact that it doesn't eliminate humans out of the process completely. So you're not just saying, yeah, we are taking all the humans out. We don't need you anymore. We have this running for us. No, it would break at a point. You need people managing it. You need people working on it. You need someone tweaking it. You need it to be escalated when issues go beyond itself, right? So as at that point, you need to keep like the humans in the loop. And maybe people in that field, maybe you have like the support engineers, maybe cloud engineers who probably think, yeah, this will probably be taking their jobs or something. But I mean, AI, ML, and all these things are here to stay. It's either you adapt to it, you make it empower you, build on it, get yourself used to it, right? And then see how you can make yourself better and then make your processes better. I think like that's the best way. So I think with the last one, we just have to keep like the humans in the loop. Then I think we're supposed to have like a short demo, but looking at the time, I don't think that would be very possible. 2 minutes? Yeah. So we can, okay. How can I share this screen? Yeah. Oh, no, you can go ahead. Okay.
So I was curious on like if I wanted to have a chatbot to support my users on a particular platform that's not AWS, would that be feasible?
I think it depends on the third-party user. So if that's the third-party application, I mean, if the third-party application probably allows programmatic access, I think everything should be possible in there. Because once it allows that, you can do anything to the Lambda function. You can probably hit those APIs. You can have those direct API calls and everything probably in the backend running Lambda function. So if that third-party application allows that, then yeah, it's very much possible. Yeah. I don't know how to share. So I'm in my console. I don't know how to switch here. It's asking me to stop sharing, but let me stop. Present, share screen. Okay, I think.
Okay, you are like okay.
All right, we're good? Cool. All right, welcome everybody. I'm going to rely on all you all to watch the time. So we're good to go though, right? Okay, cool. Okay, so my name is Tim Corey. We're going to talk about the 7 free Azure services to grow your career. The goal here is to utilize Azure to leverage your career as a software developer, as a person who's working around the software development space. Okay, so let me give you a brief overview of what we're going to be talking about today. So I've got a lot of stuff in here. This can be an hour-and-a-half talk. We're not going to do an hour-and-a-half. So at the end of this, I'll have a QR code. You can download the slides. You can look at them later. So I put a lot of material in here. We'll kind of skip through it, and don't worry if it's not all covered. It'll be in here. And you can also reach out to me later. I have a QR code later with my contact information in case you want to reach out personally. So we're going to talk first about what are some ideas around career growth we can talk about in the cloud space. How can we use cloud to leverage a career, to move yourself forward? And then we'll talk about the actual 7 free services. That's a hook you brought you here. We'll go through the 7 different ones that are fully free forever. They can use to create various things. And then from there, I have 7 honorable mentions because there's so much stuff in Azure. I didn't want you to miss some stuff. So there's 7 extras I figure we throw in here very quickly. And then at the end, we'll talk about 5 safety tips. One of the things that, especially when you're learning some of these things, that people get concerned about is, what if I wake up tomorrow morning with an $8,000 bill? I'm sure no one in this room has ever had that happen. So, you know, what can I do to make sure that I protect myself when I am learning these things, when I am telling my company, hey, let's use these things? How can I make sure that I don't say something that really messes up our company or messes up myself and my budget? Okay, so that's the kind of the overview of what we're going to talk about today. Yes. It's not showing the slides?
No.
Because we've got a split screen.
We need to change it.
Display settings right there. So who here uses Azure? Sweet. Who here is like confident in everything that Azure does? Okay, we got one liar in the room. This is true. This is true. Kevin mentioned in his talk he's got a very heavy Azure bias. I have a very heavy Azure bias as well. For a number of reasons, the biggest ones though are in the safety tips category. All the cloud services do cloud, like they all do the cloud things, and you can do, you know, storage of data. You can put data in databases. You can host websites and all the rest of the stuff in pretty much any cloud or cloud-ish service. But those safety tips, there's some things in there that can really help put some guardrails on that stuff, so you don't just, again, blow up your budget or make an absolute mess. Okay, so let's talk through the career growth ideas. Again, these ideas are supposed to be things that you kind of think through when we're looking at those services. You know, when I'm looking at a service, I'm not just saying, hey, here's a cool thing, but how can I leverage this? And so there's 4 ideas I have for you. Show off what you can do. So whenever you look at a cloud service, say, hey, could I create something in this that I can show off? Can I put something in my portfolio that says, hey, I can do Azure static web apps, and here's how. So that's one option. Another option is to get experience using cloud services. So when you're looking to apply to a job, and you say, hey, I can do Azure SQL databases because here's my ability to do it. I can show off that I've done it, and I can show off that I have experience in that area, even if I didn't have a previous job that gave me experience in that cloud service. Number 3, demo what you can do. So one of the things I encourage you is when you're learning these things, create demos. And again, that's where you can get into trouble. If you're not careful, I will show you how to do it safely. But create demos that say, this is what I can do. This is how I could do it. I could do this for you. And so by showing off what you can do, then employers can say, hey, I want that for my company. Come work for me. Okay. This is why the 7 free services are awesome. Because you've got 7 services that you can pay nothing for life and use and show off what you can do. Screen sharing the wrong screen. How about I do this? I'm going to duplicate the slideshow instead of doing presenter mode. Is that better?
When you do a presentation with PowerPoint, it extends it for you.
Oh, fine.
Go ahead and open your display settings and change to extend display, so that way you can actually force it to extend.
Gotcha. Display settings.
And then duplicate, go to extend.
Extend?
Yes.
Okay.
Now you're forcing it, so now you can share, and it should be good. And are you sharing?
No, it's not frozen because the mouse is not.
Are you on your StreamYard? Are you sharing your screen?
Yes.
Can you present to the?
Technical problem, just.
Stop share.
Stop share.
And just go ahead and present again.
Okay. So present. Share screen.
Yes, sir. And
Tiger screen.
yeah, that one right there.
This one.
There you go. Right now, when you go ahead and
How we doing? This is why I had the QR code at the end.
it's good now.
It's good now. Cool. Okay. The last one here is save your employer money. This is one that that I love. This is where you can become the hero. So if you're currently employed and want to make your boss happy, save the money. It's a real simple formula. And the way I do that is to get experience in the cloud, in these various services, and then apply that. I worked at a company once where we were spending, I believe it was $1,100 a month on hosting. We were a software as a service. And we got that down to $400 a month by adding features by putting it in the cloud. Okay? Do you think my boss is happy? Absolutely. So I told my boss, hey, we need to kind of up this bill a little bit. Not a problem. Hey, I want to try this new feature. Not a problem. We're still saving $700 a month by being in the cloud. Okay? You can spend lots more in the cloud. So be careful how you do it. But you can save your employer money. So when we're talking about these 7 services, think about these 4 things and how you might apply one or more of those. I've got a couple of ideas for you. But Azure App Services. So Azure App Services is basically websites. Okay, this is the one that probably everyone knows about, maybe has seen. But you get 10 free websites for life. Okay, so of those 10 websites, you get 1 gigabyte of storage and 1 compute hour per day, which sounds weird. You might say, wait, my website runs for 1 hour a day. That's not what happens. Instead, what happens is when a person makes a call to your website, however long the compute time takes to build that, that's taken against your 1 hour per day. So yes, if you have lots of hits, it may at some point time out and say, hey, you can't access this until tomorrow. That's what happens with free sites. But you have 10 free demo sites to work with, again, for life. So how to use these things? I'll kind of skip over most of these, but portfolio items, startup validation, demo sites, just showing off, hey, I can build websites. The cool thing about Azure App Service is you can deploy straight code to it. So you want to deploy straight HTML, CSS, JavaScript, cool. You want to deploy a C# app or something else, not a problem. I'm a C# dev, so I'm going to focus more on C# and .NET stuff. Sorry, you Java people. But you can deploy those things as just straight code, but you can also deploy them as containers, which means that you can deploy older versions that aren't supported, not a problem. Deploy it to app services as a container, because a container can have whatever version you want inside of it. So technically what happens behind the scenes, even if you deploy straight code, it's putting it in a container for you. So either way you're getting a container, it's just that you can give it the container itself instead of just the code. Okay, that's the first one. Again, free for life. Number 2, Azure Static Web Apps, which you say, well, that sounds very, very similar. Yes and no. Static web apps are for sites that don't need database access directly. So think an Angular site, React site, Vue site, Blazor site, or just HTML and CSS. You get 100 gigabytes of bandwidth per subscription, okay, for pretty much as many sites as you want for free. Again, for life. You get 2 custom domains. That is not per site. That's per subscription. And you get 500 megabytes of storage. So it's not a ton, but at the same time, it's a lot. Now, what happens with Azure Static Web Apps is they get deployed as a CDN around the world. So wherever your person requests your site, it finds the closest Azure that has your replicated site and gives access to it. The cool thing is I said that it's for sites that don't need database access, but that has changed because now they allow you to hook up an API to your Azure Static Web App and give API access directly to your static site. So there is more access and there is more connectivity than before. And because you're hooking that API up directly, there's even more security around that. Like nobody else can access your API, just your site. So it adds a lot of nice features. Again, how to use it, portfolio hosting. Any JavaScript, Blazor, WASM site, if you want to use it for a nonprofit or club site, it's a great option. If you go to my website, iamtimcorey.com, it's an Azure Static Web App, okay? So I host my site. Now, I pay for it, but I pay the incredibly high price for premium of $9 per month, okay? And again, globally replicated, lots of cool features and bells and whistles with that, but $9 a month replicated across the globe. I love it. My uptime is awesome, okay? That's number 2, free for life. Number 3, we've got Azure SQL databases. What you get, and this is where I love cloud, because it's so easy to understand what you get with cloud, right? So you get 100,000 vCore seconds per month. Everybody got that? You know what that means? No, we don't know. But with 32 gigabytes of storage, basically what you get is you get access to a SQL database in the cloud that you can use for demo purposes. You probably shouldn't put a really heavy load against it because it's going to time out just like a web app will, okay? So you get 100,000 vCore seconds per month. That just means that if you hit it too hard, it's going to lock up at some point. But there is a free version of Azure SQL that you can use, and you get 1 per subscription. So if you already created your first free Azure SQL database, you can't create more. How can you use it? You can create a database for your multiple portfolio items. You can cloud replicate practice databases. So one of the cool things that people don't often realize is that you can have a local SQL database, and you can say, hey, I want to back this up or have it replicate to Azure, and have my Azure be a backup of that. And at some point, switch those two. You can practice that. Try it out. Because that's one of the ways you can help your company move from local to in the cloud, is that replication system. Hobby database. Okay, so let's go with number 4, Cosmos DB. This is a newer entry. Cosmos DB is the NoSQL database from Azure. You can get 1,000 request units per second with 25 gigabytes of storage, 1 per subscription. This is actually really high. Okay, their entry-level database starts at 400 RUs per second. So 1,000 is a lot better. And this allows you to play around with NoSQL in the cloud. Okay, the cool thing about this is that with Cosmos DB, you can have different API connectivity. So you can say, hey, I'm used to SQL commands. I want to talk to Cosmos DB like SQL, and it has an API to do that. Or I want to do like MongoDB. And it allows you to translate from a different system into Cosmos very easily. So again, free for life, 1 per subscription. All right, this is a mouthful. Azure Active Directory B2C. If you're familiar with Entra, which is the new name for Azure Active Directory, it's still not this. Entra is for if you control all the logins. You create a login for someone, usually in your company, that's Entra. Used to be Active Directory. Now, this is Azure Active Directory AAD B2C. This is for consumers. Okay, so this is where you self-sign up for a subscription. So think about Amazon. You don't talk to Amazon and say, hey, can I be on your employee directory? No. What you say is, I want to sign up for an Amazon account. And they're like, no problem, fill this form out. That's what B2C is. It's for all of your consumers. This is, again, free for life. You get 50,000 monthly active users, or MAUs. So what this means is that if I have, and I use this for, if you go to suggestions.imtimcorey.com, that's where I have all my suggestions for, hey, you want new videos, new content? Put them there. I have you log in so you can track your suggestions. Well, I use AAD B2C. And if I have 50,000 people sign up in a month, and the 50,000 first, I'll have to pay for that person. However, next month, if I have 20,000 people log in, I don't pay anything, even though I have more than 50,000 subscribed because they're not active. So this is how most authentication systems work. And this is, as far as I can tell, this is the cheapest one out there. Okay, most systems are like, hey, we'll give you 10,000 MAUs. We'll give you 20,000 MAUs. B2C says we'll give you 50,000. So if you want to do authentication for pretty much anything that you want to do auth for easily, BSC is a great option for that. All right, next up, and I know this is fire hose, just take notes if you want something, okay? Azure Functions. Azure Functions are awesome. You can do really cool stuff with them as long as you don't blow your budget. So an Azure function, you get 1 million requests per month per function. That's the consumption plan. So you can have a function run up to 1 million times a month for free, for life, forever, okay? So pretty awesome stuff. When would you use that? Microservices, webhook endpoints, triggered activities. These things are really good for the idea of an Azure function. So the one I use a lot is the webhooks. So we have certain activities that happen on my training site where I say, hey, when this happens, I want you to do something. Well, how do I do that? My system says, I'll call this URL, that endpoint. And then my function takes it and does something with it, okay? So Azure Functions, again, free for life. Next up, Azure Container Apps. So this is, again, a newer one. And again, this is where the really awesome cloud definitions come in. You get 180,000 vCPU seconds. Does anyone even know what that references? The 360,000, first of all, GIB seconds. Correct. And what is that then talking about? Does anyone know?
I think it's 1024 bit.
Correct. So a gigabyte is like a gigabyte, but real. So we talk about gigabytes, we talk about 1,000 kilobytes and 1,000 kilobytes, or 1,000 bytes in a kilobyte. But really it's 1,024. And that's the real number. However, that refers to RAM, how much memory you're using, RAM seconds. So again, cloud has different terms. So this is how much RAM we're using, this is how much CPU you're using, and 2 million requests per month, 5 minutes. So that's what you get with Azure Container Apps. You can create containers for a whole bunch of things. You're already using, with Azure Web Apps or Azure App Service, you can use containers, but this is getting closer to, I hate to say Kubernetes because it's not, but it's getting closer to that type of thing where you can play around with containers talking to each other and forming bigger clusters. So kind of an entry point into that world. All right, that's the 7. Again, that's free for life. Let's talk about the honorable mentions real quick because there's a bunch of them. So file storage. Storing stuff in Azure is cheap. Storing stuff in S3 in AWS is cheap. This is what you get, but these are for the first 12 months. So you sign up for Azure, you'll get credits for a certain number of dollars, I think $200 for the first month, and then you'll also get certain services free for a year. These are free for a year. But again, storage is cheap. Key Vault, you get 10,000 transactions for the first 12 months, per month for the first 12 months. Event Grid, you get 100,000 operations per month for life. So again, if you want to start playing around with services, talking to other services, maybe set up some container apps and have them talk to Event Grid, we can use Event Grid for life for up to 100,000 operations per month. Azure Service Bus, 750 hours, 13 million operations, but again, that's for the first 12 months. API management, 1 million calls a month, and that's lifetime access. So again, API management, a newer one of those offerings. Number 6, Azure DevOps. This one, I kind of hate putting this in here because it's not Azure. And this is one of those things where I hope you know that. Azure DevOps is not Azure. Okay, it's in Azure. You can also access it outside of Azure. They call it Azure DevOps because of marketing, but really it's DevOps for anything. So if you're working with Java in AWS and never, ever, ever touching anything Microsoft, you can still use Azure DevOps, okay? And it's free for life for 5 users with unlimited private Git repos. So pretty awesome. And then Azure Signal R service, you get lifetime access to 20 concurrent connections per unit and 20,000 messages. So Signal R service, if you're not familiar, is a wrapper around WebSockets and other things. This makes connectivity between web clients easier. So that's that. Okay, we only have a couple minutes, but I want to go quickly into safety tips. So safety tip number 1, use resource groups effectively. If you don't know, resource groups are awesome. Resource groups are free. You just name it and say, this is the resource group. Well, when you're creating test things, give it one resource group name. And when you're done with that test thing, don't delete the test thing, delete the resource group. If you do that, it will delete every resource associated with what you created under that resource group. Which means if you create a virtual machine and it created a network and it created a storage account and it created something else for you, if you delete just the virtual machine, you might not get all those other things. If you delete the resource group, you get everything, okay? That's pro tip number 1. Number 2, pricing calculator. Make sure you know how to use that. If you don't know where that is, I never know where it is. I have to go to Google, I type Azure pricing calculator. It's always the first result. This will tell you exactly how much things cost. And you can play around and say, hey, I can change this and get a better rate. Number 3, budget alerts. This is an absolute must. If you're testing and you think you're not going to spend any money, set up a budget alert. You say, well, I'm not going to spend any money. Yes, set up a budget alert for $1. Make sure that you get an email that says you spent $1. Because if you get that, you're like, I've messed something up. But I've messed it up early enough that I can go and fix it right now. Okay? So if you're doing these in production, for example, I had a case where I think I was spending about $120 a month. I set up an alert for $60. You got to do the math on that and say, okay, I've spent $60. How many days left in the cycle are there? And do the math and say, okay, 14, we're good to go. If it says 27, I've got a problem. But I've only spent half my budget. Okay? Number 4, start small and grow. Don't go into Azure and try and create all this stuff all at once. That's huge. Start small and grow up. Okay? And number 5, don't just get a VM in the cloud. This is the kind of the concise way of saying don't just do what you're doing on-prem in the cloud. Think differently about the cloud. Okay? And that's it for the speed run. So this is for the slides. That's for connecting to me. If you have any questions, please let me know. All right? Thank you. Don't do VMs.
No.
You next? All right, I'll get under here.
Great talk.
So who here has worked? Raise your hand if you. Thank you. This is working. So who here has worked? Objective. This presentation. And You put it in the URL